Throughout human history, people have struggled with a profound question. What exactly are we? Are we purely physical beings, or something more than the sum of our physical parts? One of the most compelling answers is the idea that we consist of two fundamentally different aspects: our material bodies and our immaterial minds. This is called dualism, the philosophical view that has profoundly shaped how we understand ourselves and our place in the universe for centuries. Dualism is probably the oldest and most intuitive way to think about the mind. It basically says that your mind and your body are two totally different things. You've got physical stuff, your brain, your body, and mental stuff, your thoughts, your feelings, and their separate substances. When you feel the weight of your blanket on your body while thinking about tomorrow's plans, dualists would say you're experiencing the interaction of two fundamentally different realities: the physical sensation of weight and the non-physical activity of thinking. The most famous dualist was a French guy named René Descartes, who lived in the 1600s. He's the man who famously quoted, "I think, therefore I am." Descartes argued that the mind is non-physical. It doesn't take up space, it can't be measured or weighed, and it doesn't follow the laws of physics. Your body, on the other hand, is just physical stuff that works like a complicated machine. This specific version, Cartesian dualism, places the connection between mind and body in the pineal gland of the brain. The big question dualism struggles with is how these two different substances actually interact. If my mind is non-physical, how the hell does it make my physical body move? When I decide to raise my arm, how does this non-physical decision translate into actual motion? This is called the interaction problem, and it's a major headache for dualists. Think about it this way. If you believe in ghosts, you probably wonder how a ghost, which is non-physical, could move objects or make sounds, which are physical effects. It's the same problem. Despite these issues, dualism feels right to a lot of people. When you have a thought or feeling, it doesn't seem like it's just neurons firing in your brain. It feels like something more, something beyond the physical. And many religious and spiritual traditions embrace some form of dualism, with concepts like the soul or spirit being separate from the body. Modern science has largely rejected dualism because it doesn't fit well with what we know about the brain. We've found that when parts of the brain are damaged, aspects of the mind are affected in predictable ways. If you damage the occipital lobe, vision is impaired. If you damage Broca's area, speech is affected. This suggests a very tight connection between brain and mind, challenging the dualist perspective. But dualism hasn't completely disappeared. Some philosophers and scientists still argue that consciousness just can't be explained in purely physical terms. They point to the subjective experience of being conscious, what it feels like to see red or feel pain, and argue that these experiences, called qualia, can't be reduced to mere brain activity. This explanatory gap keeps dualism alive in modern discussion. Materialism. Materialism says everything in the universe is physical stuff: atoms, energy, fields, and nothing else. Your mind, it's just your brain doing its thing. Your thoughts, feelings, hopes, and dreams, they're all just patterns of neurons firing. There's no soul, no spirit, no ghostly mental substance floating around. This view stands in direct opposition to dualism. Where dualists say the mind is something separate from the physical world, materialists say, nope, it's all physical, all the way down. The appeal of materialism is its simplicity. It doesn't require us to explain how a non-physical mind interacts with a physical body because there is no non-physical mind. Problem solved. Plus, it fits nicely with modern science, which has been wildly successful at explaining the world in purely physical terms. Imagine you're watching a movie on your computer. The story, characters, and emotions all seem to exist in this rich, vivid way. But ultimately, it's just pixels lighting up on a screen, which itself is just electrons moving through circuits. Materialists view the mind similarly. The experience seems rich and special, but it's ultimately just the brain in action. Materialists point to plenty of evidence. Brain damage affects specific mental functions in predictable ways. Drugs alter consciousness by changing brain chemistry. When you're asleep and not conscious, your brain shows different patterns of activity. All this suggests the mind is what the brain does, not something separate. The strongest form of materialism, sometimes called eliminative materialism, goes even further. It says that our everyday concepts like beliefs, desires, and even consciousness itself are kind of like outdated theories that will eventually be replaced by a more accurate neuroscientific understanding. It's like how we no longer talk about humors in the body or phlogiston in chemistry. But materialism faces serious challenges. The biggest one is explaining subjective experience. Sure, we can identify which parts of the brain light up when you see the color red, but why does seeing red feel like something? Why is there an experience at all? This is what philosopher David Chalmers calls the hard problem of consciousness. Despite these challenges, materialism remains the dominant view among scientists and many philosophers. It's straightforward. It avoids mysticism, and it doesn't require any weird metaphysical additions to our understanding of the physical world. Idealism. Imagine if I told you that the world around you, the chair you're sitting on, the device you're reading this on, even your own body, doesn't actually exist as physical stuff. Instead, everything is mental. Reality is made of mind, consciousness, or ideas. That's the wild claim of idealism. It sounds crazy at first, but idealism has a long and respected history in philosophy. George Berkeley, an 18th century Irish philosopher, was one of its most famous advocates. Berkeley argued that things only exist when perceived. His famous line was, "To be is to be perceived. No perception, no existence." Think about it. Everything you experience, colors, sounds, textures, comes to you through your consciousness. You never experience the thing in itself directly. You only ever experience your perception of things. So how do you know there's anything beyond perception at all? Berkeley wasn't saying the world is an illusion. He was saying that reality is fundamentally mental rather than material. But who's doing all this perceiving when nobody's around? Berkeley's answer was God, the ultimate perceiver who keeps things in existence even when no humans are looking. Modern idealists don't necessarily invoke God. Some, like philosopher Bernardo Kastrup, suggest that consciousness is fundamental to reality, not produced by brains, but expressed through them. In this view, our individual minds are like whirlpools in a universal sea of consciousness. The biggest strength of idealism is that it deals with the hard problem of consciousness directly. Instead of trying to explain how physical stuff gives rise to consciousness, which seems impossible to many, it starts with consciousness as fundamental. Problem solved. But idealism faces its own challenges. If everything is mental, why does the world seem so structured and law-like? Why can't we just think things into existence? And why do we all seem to share the same reality if it's all in the mind? Idealists have answers, of course. They suggest that the laws of nature are really laws of consciousness, consistent patterns in how reality manifests. And our shared reality exists because our individual consciousnesses are connected at a deeper level. While materialism dominates modern science, idealism has made something of a comeback in recent years, especially among philosophers struggling with the hard problem of consciousness. Some prominent scientists, like physicist Bernardo Kastrup and neuroscientist Donald Hoffman, have also proposed idealist models of reality. Is reality fundamentally mental rather than physical? It's a profound question with no easy answer. Panpsychism. What if consciousness isn't just happening in your head? What if it's everywhere, in everything? That's panpsychism. The idea that consciousness is a fundamental feature of the universe, present in all things in some form, from humans to honeybees, from mushrooms to mountains, maybe even down to electrons and quarks. This isn't saying your coffee mug has thoughts or feelings like you do. It's suggesting that the basic building blocks of reality might have some extremely simple form of experience, a kind of proto-consciousness that, when organized in complex systems like brains, gives rise to the rich conscious experience we humans have. Panpsychism sounds wild to modern ears, but it's actually one of humanity's oldest ideas. Many indigenous cultures viewed everything as having spirit or consciousness. Ancient Greek philosophers like Thales said, "All things are full of gods." It fell out of favor in Western thought during the scientific revolution, but has been making a serious comeback. Why would anyone take this seriously? Because it offers an elegant solution to the hard problem of consciousness, how subjective experience arises from physical stuff. Materialists struggle to explain how non-conscious matter suddenly becomes conscious when arranged in brains. Dualists can't explain how a non-physical mind interacts with the physical body. Panpsychism sidesteps these problems by saying consciousness doesn't emerge at some point. It's been there all along, just in simpler forms. It suggests there's no sharp dividing line between conscious and non-conscious things, just a spectrum of complexity. Philosopher Galen Strawson argues that panpsychism is actually more compatible with physics than materialism. He points out that physics tells us about the mathematical and structural properties of things, but stays silent about their intrinsic nature. That intrinsic nature, he suggests, could involve experience. There are legitimate objections, of course. A big one is the combination problem. How do all these tiny conscious entities combine to form our unified conscious experience? If every atom in my brain has some tiny speck of consciousness, how do they come together to create my single, unified experience? Another objection. If consciousness is everywhere, why does it seem so closely tied to specific brain states? When parts of your brain are damaged or when you're anesthetized, your consciousness is affected in predictable ways. Despite these challenges, panpsychism has attracted serious thinkers like philosophers David Chalmers and Philip Goff, and neuroscientist Christoph Koch. It occupies a middle ground between the stark materialism that dominates science and more spiritual views of consciousness. Monism. Monism boils down to a simple idea. There's only one kind of fundamental stuff that makes up everything in reality. Unlike dualism, which says mind and matter are two different substances, monism says, nah, it's all just one thing at the bottom. Think of it like ice, water, and steam. They seem different, but they're all just H2O in different forms. Monists argue that mind and matter might seem different, but they're actually just different expressions of a single underlying reality. There are different flavors of monism. Materialist monists say everything is physical. Consciousness, thoughts, feelings are just physical processes in the brain. Idealist monists flip this and say everything is mental. What we think of as physical objects are actually collections of experiences or ideas. Neutral monists take a different approach, suggesting that the fundamental stuff of reality is neither mental nor physical, but something that can manifest as either. Baruch Spinoza, a 17th century philosopher, developed a sophisticated form of monism. He argued that there's only one substance, which he identified with both God and nature. This substance has infinite attributes, but we humans can only perceive two, mind and matter. For Spinoza, mind and matter are different ways of viewing the same underlying reality. Think of it like a coin. It has two sides that look completely different, but they're aspects of the same object. Spinoza would say consciousness and physical processes are like the two sides of the coin. They appear different, but are ultimately the same underlying stuff viewed from different perspectives. The appeal of monism is that it avoids the interaction problem that plagues dualism. If mind and matter are fundamentally the same stuff, then there's no mystery about how they interact. They're just different aspects of the same reality. Modern physics has given monism a boost. In quantum mechanics, the line between observer and observed gets blurry. Some interpretations suggest that consciousness might play a role in determining physical reality, and Einstein's discovery that matter and energy are interconvertible, E equals mc squared, showed that things we thought were fundamentally different are actually the same. Monism provides an elegant philosophical framework, but it faces challenges too. If everything is one kind of stuff, why does the mental seem so different from the physical? How exactly does this one substance manifest as both consciousness and physical objects? These questions don't have easy answers. Still, monism remains appealing because it promises to unify our understanding of reality, bringing together the mental and physical under one conceptual umbrella. Physicalism. Physicalism is kind of like materialism's more sophisticated cousin. While materialism says everything is physical matter, physicalism broadens the picture and says everything that exists is either physical or depends on the physical. This might sound like nitpicking, but it's an important distinction. The universe as described by modern physics isn't just chunks of matter. It includes energy, fields, waves, forces, and weird quantum stuff that doesn't really fit the old idea of material. Physicalism embraces all this and says, this is what's real. Everything else, minds, consciousness, thoughts, must somehow be explained in terms of these physical things. Imagine you're looking at a beautiful painting. A physicalist would say the painting's beauty isn't some separate non-physical quality floating above the canvas. It's just a particular arrangement of physical pigments that, when processed by your equally physical brain, produces certain experiences and responses. Similarly, consciousness itself must be either identical to brain processes or somehow produced by them. Your thoughts, feelings, and sense of self aren't separate from the physical world. They're complex patterns of neurons firing, chemical reactions, and electrical activity in your brain. The strongest argument for physicalism is simple. It works. Our scientific understanding of the physical world has been incredibly successful at explaining everything from stars to cells to brain. We've repeatedly found that phenomena once thought to require non-physical explanations, like life itself, turned out to be explainable in physical terms. Why should consciousness be any different? Plus, we know that consciousness depends heavily on the brain. Change the brain through injury, drugs, or sleep, and consciousness changes in predictable ways. This suggests a tight connection between physical processes and conscious experience. Critics of physicalism point to what philosopher Joseph Levine called the explanatory gap, our inability to explain how physical processes give rise to subjective experiences. We can describe all the physical processes involved in seeing the color red, but that doesn't tell us what it feels like to see red. This felt quality seems to escape physical description. Some critics go further and argue that physicalism simply can't account for consciousness because physical descriptions are always about structure, function, and relationships, while consciousness is about what it feels like from the inside. Physicalists respond that the explanatory gap might just reflect limitations in our current understanding. After all, earlier generations couldn't explain how life works, but that didn't mean life was non-physical. Given time and research, physicalists believe we'll eventually bridge the gap between physical processes and conscious experience. Functionalism. Functionalism shifts the conversation about consciousness in a fascinating way. Instead of obsessing over what consciousness is made of, physical stuff, mental stuff, functionalists focus on what consciousness does. It's like saying, don't tell me what your car's engine is made of, tell me how it works. According to functionalism, mental states are defined by their functional role, the job they do in our overall cognitive system. Pain, for example, isn't defined by what it's made of, but by what it does. It's typically caused by tissue damage, produces certain behaviors, like wincing, creates the desire to avoid similar situations in the future, and so on. The beauty of functionalism is that it allows for multiple ways to implement the same mental state. Just as a mousetrap could be made of wood, plastic, or titanium and still function as a mousetrap, consciousness could potentially be realized in different physical or even non-physical systems. This opens up the possibility that radically different systems could be conscious if they're functionally organized in the right way. A computer, an alien with a silicon-based brain, or some future artificial intelligence might all be conscious if they implement the right functional relationships, even though they're made of completely different stuff than our brains. Hilary Putnam, one of functionalism's early champions, compared the mind to software running on the hardware of the brain. Just as the same software can run on different computers, the same mental processes could theoretically run on different physical substrates. This analogy helped inspire the computational theory of mind, the idea that thinking is essentially information processing, like what computers do, but vastly more complex. If consciousness is just a particularly sophisticated kind of information processing, then any system that processes information in the right way could be conscious. Functionalism has been enormously influential in cognitive science, AI research, and philosophy of mind. It sidesteps thorny metaphysical questions about the stuff of consciousness by focusing on something more measurable and testable, how mental systems function. But functionalism faces serious challenges too. Critics argue that it misses something essential about consciousness, the subjective, qualitative feel of experience. Knowing all the functional roles of seeing red doesn't tell you what it feels like to see red. This is the Qualia problem, explaining why mental states feel like something from the inside. John Searle's famous Chinese room thought experiment, which we'll cover later, targets functionalism by arguing that running the right program isn't sufficient for understanding or consciousness. Despite these challenges, functionalism remains a powerful framework for understanding the mind, especially for researchers trying to build artificial intelligence or understand consciousness across different species. Representationalism. When you see a tree, smell coffee, or feel pain, what's happening in your mind? Representationalism says you're not directly experiencing the world itself. You're experiencing mental representations of it. Your conscious experience is basically a model your brain builds to help you navigate reality. Think of it like this. Your brain is locked inside your skull, receiving electrical signals from your sense organs. It never directly touches the world outside. Instead, it constructs an internal model based on those signals, a representation of reality. When you see a red apple, you're not directly experiencing the apple. You're experiencing your brain's representation of it. This might sound like common sense, but representationalism makes a stronger claim. The content of your conscious experience, what it's like to see red or feel pain, is determined by what your mental states represent. The feeling of pain represents bodily damage. The experience of seeing red represents certain wavelengths of light hitting your retina, and so on. One strength of representationalism is that it helps explain how we can have experiences of things that aren't actually present. When you hallucinate, dream, or remember something, you're experiencing representations without the corresponding external reality. The same mechanisms that normally represent reality are just operating without their usual inputs. Representationalism comes in different flavors. First-order representationalists like Fred Dretske and Michael Tai argue that conscious experiences are just representations that play a certain functional role in guiding behavior. Higher-order representationalists like David Rosenthal suggest that consciousness involves representations of representations. You become conscious of seeing red when you form a higher-order thought about your perception. But representationalism faces challenges. The biggest one is explaining why representations feel like something. Your phone's camera represents the world, but presumably doesn't have conscious experience. What makes neural representations different? Critics like Ned Block argue that representationalism conflates two aspects of consciousness: access, the availability of information for reasoning and action, and phenomenology, the subjective feel of experience. Another issue: if my experience of red is just a representation, what makes it a representation of red specifically? Some philosophers argue that representational content is determined partly by causal connections to the environment, others by biological function, and still others by conceptual role. Despite these challenges, Representationalism offers a promising framework for understanding consciousness, especially as neuroscience advances our understanding of how the brain represents the world. It bridges the gap between subjective experience and scientific accounts of brain function, making it popular among both philosophers and scientists studying consciousness. Emergentism. Sometimes the whole is greater than the sum of its parts. Water has properties that hydrogen and oxygen alone don't have. A hurricane has behaviors that individual air molecules don't. This is emergence, when complex systems develop features that their components lack. Emergentism applies this idea to consciousness, suggesting that awareness emerges from brain activity in ways that couldn't be predicted by looking at neurons alone. Imagine an ant colony. Individual ants follow simple rules, but together they build complex structures, find food efficiently, and defend against threats. The colony's intelligence emerges from countless simple interactions, creating something that seems almost purposeful. Emergentists suggest consciousness works similarly. It's a higher-level property that arises from the intricate dance of neurons. Emergentism occupies a middle ground between reductive materialism, which says consciousness is nothing but neural activity, and dualism, which says consciousness is something separate from the physical brain. Instead, emergentism says, yes, consciousness is ultimately physical, but it can't be reduced to or predicted from basic physics. There are different flavors of emergentism. Weak emergence says that while consciousness emerges from physical processes, it could theoretically be predicted or explained if we had complete knowledge of those processes. It's just that the systems are too complex for our current understanding. Strong emergence makes a bolder claim. Even with perfect knowledge of all physical details, you couldn't predict or explain consciousness. It represents something genuinely new in the universe. John Stuart Mill, a 19th century philosopher, used the example of water to illustrate emergence. Water's properties, like transparency and fluidity, can't be found in hydrogen or oxygen alone. Similarly, consciousness might be a novel property that emerges from neural systems of sufficient complexity. Modern emergentists often point to complex systems theory. In complex systems, simple elements following simple rules can generate astonishingly complex patterns and behaviors, like weather systems forming from air molecules, or market trends emerging from individual transactions. Consciousness might be an emergent pattern of this sort. The main criticism of emergentism is that it doesn't really explain consciousness so much as label it. Saying consciousness emerges from brain activity doesn't tell us how or why this happens. Critics like philosopher Jaegwon Kim argue that if consciousness emerges from physical processes, it must either be causally reducible to those processes, making it just complicated physical stuff, or causally irrelevant, making it an epiphenomenon. Despite these challenges, emergentism appeals to many because it acknowledges both the physical basis of consciousness and its seemingly special nature. It suggests consciousness is neither magical nor mundane. It's what happens when matter organizes itself in extraordinarily complex ways. Epiphenomenalism. Epiphenomenalism is like being a passenger in a self-driving car. You see where the car is going, you experience the journey, but you have no control over the steering wheel, gas pedal, or brakes. According to this theory, consciousness is just along for the ride, while physical processes in the brain do all the real work. The core idea is that physical events in the brain cause conscious experiences, but those experiences don't cause anything physical in return. Your thoughts, feelings, and sensations are real, but they're causally impotent, like shadows cast by objects, but unable to affect those objects. When you decide to raise your arm, it's actually neural processes in your brain causing both your arm to rise and the feeling of having made a decision. This bizarre-sounding view was popularized by philosopher Thomas Huxley in the 19th century. He compared consciousness to the steam whistle on a locomotive, produced by the engine's working but not driving the train. Modern epiphenomenalists similarly argue that consciousness is produced by brain activity but doesn't influence physical events. Why would anyone believe this? One reason is the causal closure of the physical world. Physics seems to provide complete explanations for physical events without needing to invoke consciousness. If every physical event has sufficient physical causes, what causal work is left for consciousness to do? Another motivation comes from the problem of mental causation. If consciousness is non-physical, as dualists claim, how could it possibly affect the physical brain? Epiphenomenalism avoids this problem by saying it doesn't. Consciousness is caused by physical processes, but doesn't cause anything physical itself. But epiphenomenalism faces serious challenges. The biggest is evolutionary. Why would consciousness evolve if it doesn't do anything? Natural selection only preserves traits that provide survival advantages, and a causally impotent consciousness wouldn't offer any advantage. Another objection: we constantly talk about our conscious experiences. If consciousness can't cause physical events, how can we talk about it? The epiphenomenalist must claim that neural processes cause both our conscious experiences and, independently, our talk about those experiences, an oddly coincidental arrangement. Perhaps most damning is that epiphenomenalism contradicts our deepest intuitions about ourselves. We feel that our conscious thoughts and feelings matter, that they make a difference to what we do. The idea that consciousness is just a powerless byproduct of brain activity seems to rob human experience of its meaning and significance. Despite these problems, epiphenomenalism remains an important theory in philosophy of mind, because it highlights the difficulty of explaining how consciousness could have causal powers in a physical world that seems causally complete without it. Higher order theories. What's the difference between just perceiving something and being consciously aware of perceiving it? Higher order theories suggest that consciousness isn't about having perceptions, thoughts, or feelings. It's about being aware that you're having them. Imagine you're driving home on autopilot while lost in thought. Your brain is processing the road, traffic lights, and other cars, first-order representations, but you're not consciously aware of seeing them. According to higher-order theories, what's missing is a second level of mental activity, higher-order representations that are about your first-order states. In other words, consciousness happens when your mind turns its attention to its own operation. You become conscious of seeing a red apple when you have a thought like, "I am seeing a red apple," even if this higher-order thought isn't explicit or articulated. David Rosenthal's higher-order thought theory is a prominent version of this approach. Rosenthal argues that what makes a mental state conscious is that it's the object of a higher-order thought. These higher-order thoughts aren't themselves conscious. That would lead to an infinite regress. They simply make their targets conscious by representing them. Other versions include higher-order perception theory, which suggests that instead of thoughts, it's a kind of inner perception or scanning of our mental states that makes them conscious. Imagine a mental eye that monitors your first-order states. Higher-order theories have several strengths. They explain why we can have unconscious mental states, those not targeted by higher-order representations. They account for our ability to report on our conscious experiences, and they align with the common intuition that consciousness involves a kind of self-awareness. But these theories face challenges too. Critics argue that higher-order theories allow for empty, higher-order representation. You could have a higher-order thought about seeing red when you're not actually seeing anything. Should this count as conscious experience? Another objection is that higher-order theories seem to conflate consciousness with introspection or reflection. Animals and infants presumably have conscious experiences without sophisticated higher-order thinking abilities. Neuroscientific evidence is mixed. Some studies suggest that areas of the prefrontal cortex associated with higher-order thinking are necessary for consciousness, supporting these theories. But other evidence indicates that primary sensory areas can support consciousness without higher-order activity. Higher-order theories remain influential because they offer a clear mechanism for consciousness. It's simply what happens when the mind represents its own operations. They also fit well with cognitive theories of mind and may be easier to implement in artificial systems than approaches that treat consciousness as a mysterious, primitive property. Whether consciousness truly requires higher-order awareness remains one of the central questions in the science and philosophy of mind. Global workspace theory. Imagine your brain as a massive corporation with thousands of specialized departments working simultaneously. Most of these departments operate behind the scenes, processing information without your awareness. But sometimes, information from one department gets broadcast across the entire company, becoming available to everyone. That broadcast is consciousness, according to global workspace theory. Developed by psychologist Bernard Baars in the 1980s, this theory suggests that consciousness emerges when information is widely shared across the brain. Most brain processes work in parallel, processing information unconsciously. But a small amount of information can enter what Baars calls the global workspace, a kind of mental bulletin board that distributes information to many different brain systems at once. Think about what happens when you're driving and suddenly notice a child running into the street. This information immediately becomes conscious, triggering responses across multiple brain systems. Visual processing sharpens, motor systems prepare for action, memory systems activate related experiences, emotional systems generate alarm. The information about the child has entered the global workspace, making it globally available throughout the brain. What makes global workspace theory powerful is that it explains both what consciousness does and why it evolved. Consciousness serves as a bottleneck that allows only the most important information to be broadcast widely. This prevents the brain's specialized systems from working at cross purposes and enables them to collaborate on solving complex problems. The theory aligns well with our subjective experience. Conscious thoughts feel unified and accessible. We can report them, reason about them, store them in memory, and use them to guide action. Unconscious processes, by contrast, operate outside our awareness and control. Neuroscientists have found evidence supporting this theory. Studies using brain imaging show that when information becomes conscious, neural activity spreads from specialized sensory regions to a broader network involving the prefrontal cortex, parietal cortex, and other regions. This pattern of widespread activation is consistent with the idea of a global broadcast. Stanislas Dehaene, a leading cognitive neuroscientist, has expanded the theory into what he calls the global neuronal workspace model, linking it more directly to specific brain mechanisms and neural signatures of consciousness. The theory faces challenges, of course. Critics argue that it better explains access consciousness, information available for reporting and reasoning, than phenomenal consciousness, the subjective experience or feeling of consciousness. The broadcast mechanism might explain how information becomes available for cognitive processing, but does it explain why there's something it feels like to be conscious? Despite these limitations, global workspace theory remains one of the most influential scientific theories of consciousness, providing a framework that bridges philosophy, psychology, and neuroscience. Integrated information theory. Imagine you're looking at a red rose. The experience isn't just a collection of separate sensations, the redness, the smell, the shape. It's a unified whole. This integration is the key to consciousness according to Integrated Information Theory, IIT, a bold framework developed by neuroscientist Giulio Tononi that attempts to explain what consciousness is, how it works, and where it exists. IIT flips the traditional approach to consciousness. Instead of starting with the brain and asking how it produces consciousness, IIT starts with the properties of conscious experience and asks what kind of physical system could support them. Consciousness, according to IIT, is integrated information. When a system integrates information in just the right way, when the whole contains more information than the sum of its parts, consciousness emerges. The theory quantifies this integration with a value called phi, the The higher the phi, the more consciousness. Think of it this way. Your brain integrates information across billions of neurons, creating a unified experience much richer than what any single neuron processes. A digital camera, by contrast, processes information pixel by pixel without much integration, so it has very low phi and presumably little or no consciousness. What makes IIT radical is that it treats consciousness as a fundamental property of reality, like mass or charge. Consciousness isn't produced by the brain. It's a property that systems have to varying degrees based on their causal structure. The brain is conscious because its architecture enables high information integration. This leads to some wild implications. IIT suggests consciousness exists in a spectrum. Humans have a lot, animals less, depending on their neural complexity. And even simple systems might have tiny amounts. It's potentially compatible with Panpsychism, the idea that consciousness exists throughout the universe. IIT makes testable predictions. It suggests which brain structures should be crucial for consciousness, like the cerebral cortex, and which shouldn't, like the cerebellum, despite having more neurons. It predicts that consciousness should disappear in certain types of seizures, where neural activity becomes too synchronized, and it might eventually allow us to measure consciousness in people who cannot communicate, like those in vegetative states. Critics argue that IIT confuses correlation with causation. Just because consciousness correlates with integrated information doesn't mean that's what consciousness is. Others question whether phi truly captures what matters about consciousness, and some find its panpsychist implications too far-fetched. Despite these criticisms, IIT remains one of the most ambitious scientific theories of consciousness. Unlike frameworks that just describe neural correlates of consciousness, IIT attempts to explain why consciousness exists at all and how it relates to physical reality. The hard problem of consciousness. Imagine scientists have figured out everything about the brain. Every neuron, every connection, every chemical and electrical signal. They can predict with perfect accuracy what your brain will do in any situation. Would they have explained consciousness? According to philosopher David Chalmers, who coined the term hard problem of consciousness in 1995, the answer is no. The hard problem is about explaining why we have subjective experiences at all. Why does it feel like something to be alive? Why is there an internal movie playing in our heads? Why aren't we just complex robots going through the motion without any inner life? To understand the hard problem, it helps to contrast it with what Chalmers calls the easy problems of consciousness. These include explaining how we focus attention, integrate information, report on mental states, and so on. They're not actually easy. They're incredibly complex, but they're solvable in principle using the tools of neuroscience and cognitive psychology. The hard problem is different. It's not about what consciousness does, but about why there's something it feels like to be conscious. Even if we knew every detail about how the brain processes visual information, when you look at a sunset, we still wouldn't have explained why seeing a sunset feels the way it does. That rich, subjective experience of oranges and reds and purples. There seems to be an explanatory gap between physical processes and subjective experience. This gap bothers many scientists and philosophers because science has been so successful at explaining everything else. We've explained life in terms of chemistry and biology, chemistry in terms of physics, and so on. But consciousness seems to resist this kind of explanation. Responses to the hard problem fall into several camps. Some, like Daniel Dennett, deny there's a hard problem at all. Once we've solved all the easy problems, there will be nothing left to explain. Others accept the problem, but think we can solve it with new scientific approaches. Still others, like Chalmers himself, suggest we might need to revise our understanding of physical reality, perhaps by including consciousness as a fundamental feature alongside things like mass and charge. The hard problem has profound implications. If consciousness can't be explained in purely physical terms, it challenges physicalism, the dominant view in science. It raises questions about consciousness in other species and potentially in artificial systems. And it touches on age-old philosophical questions about the nature of reality and our place in it. Whether the hard problem is solvable or not remains one of the most contested questions in the study of consciousness. But the question itself has transformed how we think about the mind, pushing us to confront the mysterious nature of subjective experience. Explanatory gap. Imagine a color scientist who knows everything about how the brain processes color. She understands the physics of light wavelengths, how retinal cells respond, how signals travel through the optic nerve, and how the visual cortex processes this information. But she's been colorblind from birth, never having experienced color herself. Would all this knowledge tell her what it's like to see red? This scenario, inspired by philosopher Frank Jackson's Mary the Color Scientist thought experiment, illustrates what philosopher Joseph Levine called the explanatory gap, the apparent gulf between physical explanations of brain processes and the subjective experience of consciousness. The explanatory gap highlights a fundamental issue. Physical accounts of the brain tell us about structure and function, which neurons connect to which, what chemicals are released, what areas activate under what conditions, but they seem to leave out the subjective quality of experience, what philosophers call qualia. For example, neuroscience can explain in detail what happens in your brain when you feel pain, but the explanation doesn't capture what pain feels like, that raw, unpleasant sensation that makes you want to avoid it. There seems to be a gap between explaining the mechanisms of pain processing and explaining the experience of pain itself. Levine introduced this concept in 1983 to highlight a limitation in physicalist theories of mind. Unlike the hard problem of consciousness, which questions whether physical explanations can ever account for subjective experience, the explanatory gap doesn't necessarily claim that consciousness can't be physical. It just points out that our current physical explanations don't bridge the gap between objective descriptions and subjective experience. Some philosophers, like Colin McGinn, take the explanatory gap as evidence of cognitive closure. The idea that human minds might be fundamentally incapable of understanding how physical processes give rise to consciousness, just as a mouse can't understand quantum physics. Others, like Paul and Patricia Churchland, argue that the gap is temporary. As neuroscience advances, we'll develop concepts and theories that bridge the divide. The explanatory gap has practical implications for fields like artificial intelligence and animal welfare. If we can't explain how physical systems give rise to conscious experiences, how can we know whether AI systems or different animal species are conscious? Are we missing something crucial when we study consciousness solely through its physical correlates? Whether the explanatory gap represents a permanent limitation in our understanding or merely a challenge to be overcome remains an open question. But it continues to push scientists and philosophers to develop richer, more nuanced theories of how the physical and the phenomenal might be connected. Qualia. What's it like to see the color red, to taste chocolate, to feel pain? These subjective experiences, the raw fields of consciousness, are called qualia, singular, qual. They're the qualitative aspects of our mental lives, the what-it's-likeness of experience that seems so hard to capture in objective scientific terms. Qualia are deeply personal and seem directly accessible only to the person experiencing them. I know what red looks like to me, but I can never truly know if you experience it the same way. Maybe what I call red looks like what you'd call blue if you could see through my eyes. But since we both learned the same word for the same objects, we'd never know the difference. This privacy and ineffability of qualia creates profound philosophical problems. How can something as subjective as the taste of pineapple or the feeling of sadness fit into our scientific picture of the world, which is built on objective third-person descriptions? Physics, chemistry, and biology describe the world in terms of particles, forces, molecules, and cells. But where do qualia fit in? Philosophers have taken various positions on qualia. Some, like Daniel Dennett, argue that qualia are illusions, useful fictions that don't really exist in the way we think they do. On this view, once we explain all the functional aspects of perception and cognition, there's nothing left to explain. Others, like David Chalmers, see qualia as real phenomena that require special explanation, perhaps even requiring us to expand our scientific worldview beyond purely physical properties. The existence of qualia raises thorny questions about artificial intelligence and animal consciousness. Could a sophisticated AI system ever experience qualia? How do we know which animals have conscious experiences? Without access to another being's subjective states, these questions seem almost impossible to answer definitively. Qualia also feature in famous thought experiments like the inverted spectrum. Could your experience of colors be systematically different from mine? And philosophical zombies. Could a being physically identical to me lack conscious experiences entirely? These thought experiments push us to consider whether qualia can be reduced to physical processes, or whether they represent something beyond the physical world. Some scientists approach qualia by studying neural correlates of consciousness, the brain activities that correspond to particular conscious experience. But critics argue this approach only identifies correlations, not explanation. It doesn't tell us why certain brain states feel like something from the inside. Whether qualia can be explained in physical terms or represent something fundamentally different from the physical world remains one of the central mysteries in the study of consciousness. The raw feels of experience, the redness of red, the painfulness of pain, continue to resist our attempts to fully capture them in objective terms. The Chinese room. Imagine a man locked in a room with boxes of Chinese symbols and a rulebook. Through a slot in the wall, he receives cards with Chinese writing. Using the rulebook, he matches patterns of symbols and sends appropriate responses back through the slot. To Chinese speakers outside, it appears they're having a conversation with someone who understands Chinese. But here's the catch. The man inside doesn't understand a word of Chinese. He's just following rules for manipulating symbols. This is philosopher John Searle's famous Chinese room thought experiment, introduced in 1980 to challenge the idea that computers could ever truly understand language or be conscious merely by running the right program. Searle's argument targets functionalism and the computational theory of mind. These theories suggest that mental states are defined by their functional role, and that consciousness could emerge from any system that implements the right functional organization, whether it's a brain, a computer, or something else entirely. The Chinese room suggests otherwise. The man in the room perfectly simulates understanding Chinese. Functionally, he behaves exactly like someone who understands the language. But intuition tells us he doesn't actually understand Chinese. He's just manipulating meaningless, to him, symbols according to rules. Similarly, Searle argues, a computer running a program doesn't understand the symbols it manipulates. It just follows instructions blindly. No matter how sophisticated the program, no matter how convincingly it simulates understanding, something essential is missing. The actual comprehension, the semantics, the meaning. Responses to the Chinese room have been varied and vigorous. The system's reply argues that while the man doesn't understand Chinese, the entire system, man plus rulebook plus symbols, does. Just as individual neurons don't understand language, but the brain as a whole does. Searle counters that the man could internalize the entire system, memorizing all rules and performing all operations mentally, yet still not understand Chinese. Other critics argue that Searle relies too heavily on intuition. Maybe what feels like understanding to us is just a particularly complex form of symbol manipulation after all. Or perhaps understanding emerges gradually as systems become more sophisticated rather than being all or nothing. The Chinese room connects to broader questions about consciousness. Can consciousness emerge from purely syntactic operations, or does it require something more? Is there something special about biological brains that artificial systems might never duplicate? Where does meaning come from? Whether you find Searle's argument convincing or not, The Chinese room has shaped decades of debate about artificial intelligence, consciousness, and what it means to truly understand something. It reminds us that simulating a mental phenomenon might be very different from actually having it. Philosophical zombies. What if there was someone who looked like you, talked like you, and behaved exactly like you in every way, but had no conscious experiences whatsoever? No feelings, no sensations, nothing it was like to be them, just darkness inside. This is a philosophical zombie, or P-zombie, and it's one of the most provocative thought experiments in the philosophy of mind. Unlike the shambling corpses of horror movies, philosophical zombies are physically identical to conscious humans down to the last atom. They walk, talk, laugh, and even claim to have conscious experiences. If you pinched a P-zombie, they would say, "ouch," and pull away their hand, but they wouldn't actually feel pain. They would process all the same information and produce all the same outputs as a conscious person, but there would be nobody home inside. The concept was popularized by philosopher David Chalmers as an argument against physicalism, the view that everything in the universe, including consciousness, is physical. Chalmers argues that if P-zombies are even conceivable, then consciousness can't be explained purely in physical terms. Why? Because if consciousness were just a physical process, then any being physically identical to a conscious person would necessarily be conscious too. Imagine two worlds, one just like ours and another identical in every physical respect, except that no one in it has any conscious experiences. If such a zombie world is possible, then consciousness must be something beyond the physical, an extra ingredient not captured by physics or neuroscience. Critics like Daniel Dennett argue that P-zombies aren't actually conceivable upon closer inspection. They might seem possible at first glance, but when we really think about what it would mean for a being to act exactly like a conscious person without having consciousness, we find contradictions. After all, much of our behavior is shaped by and responds to conscious experiences. Others argue that even if P-zombies are conceivable, that doesn't mean they're actually possible. Our ability to imagine something doesn't guarantee its possibility in reality. Maybe consciousness necessarily emerges from certain physical configuration, even if we can't see why. The P-zombie thought experiment cuts to the heart of the mind-body problem. If consciousness is physical, then physically identical beings must have identical conscious states. If consciousness isn't physical, then what is it and how does it relate to the physical world? Whether you find the zombie argument convincing or not, it highlights just how mysterious consciousness remains. Something about conscious experience, the way it feels from the inside, seems to resist explanation in terms of mere physical processes and functions. Mary's room. Mary is a brilliant neuroscientist who has spent her entire life in a black and white room. She's never seen color, but she knows everything there is to know about color vision. The physics of light wavelengths, how the retina processes different colors, which neural pathways are activated when people see red or blue or green. She has complete knowledge of the physical facts about color perception. Now imagine, Mary is finally released from her room and sees a red rose for the first time. Does she learn anything new? This thought experiment, introduced by philosopher Frank Jackson in 1982, is known as Mary's room, or the knowledge argument. It challenges physicalism, the view that everything, including consciousness, can be explained in physical terms. The argument goes like this. If physicalism is true, then knowing all the physical facts should mean knowing everything. But when Mary sees red for the first time, she seems to learn something new, what it's like to experience the color red. This suggests there are non-physical facts about consciousness that can't be deduced from physical knowledge alone. The intuitive pull of the argument is strong. It seems obvious that Mary would exclaim, "So that's what red looks like," when seeing the rose, indicating she's gained knowledge she didn't have before. If physical knowledge was all there is, she should have already known what red looks like. Responses to the knowledge argument come in various forms. Some philosophers, like Daniel Dennett, Challenge the setup itself. Could Mary really know all the physical facts about color vision without ever experiencing color? Wouldn't such complete knowledge already include what it's like to see red? Others, like David Lewis, argue that Mary doesn't learn new facts, but gains new abilities. She now knows what red looks like in the sense that she can recognize and imagine it, not because she's learned some non-physical truth. The phenomenal concept strategy, developed by philosophers like Brian Law, suggests that Mary gains a new way of thinking about something she already knew. She had all the facts about red experiences, but only after seeing red could she think about those facts using concepts based on direct experience. The Mary's Room thought experiment connects to broader questions about consciousness. Can third-person, objective knowledge ever capture the first-person, subjective nature of experience? Is there an explanatory gap between physical descriptions of brain processes and what it feels like to have conscious experiences? Whether you think Mary learns something new or not, the thought experiment highlights the mysterious relationship between physical processes and conscious experience, pushing us to examine whether science, as we know it, can fully explain what it's like to be conscious. The knowledge argument. The knowledge argument is essentially a more structured version of the Mary's Room thought experiment, formalized by philosopher Frank Jackson to challenge physicalism. The view that everything in the universe, including consciousness, can be fully explained in physical terms. Here's the argument laid out formally. Mary knows all the physical facts about color vision while in her black and white room. Upon leaving the room and seeing color for the first time, Mary learns something new about color vision. Therefore, there are facts about color vision that aren't physical facts. If physicalism were true, all facts would be physical facts. Therefore, physicalism is false. The argument's power comes from its directness. If Mary truly learns something new when she sees color for the first time, then it seems physical knowledge alone can't capture everything about consciousness. There must be something beyond the physical, what philosophers call qualia, or the subjective, qualitative aspects of experience. Jackson himself initially used this argument to support dualism, the view that mind and matter are fundamentally different substances. If consciousness can't be reduced to physical facts, perhaps it's something non-physical. Interestingly, Jackson later changed his mind, deciding the argument wasn't sound after all. But the knowledge argument remains influential, continuing to challenge physicalist accounts of consciousness. Physicalists have developed several responses. Some argue that Mary gains new abilities rather than new knowledge. She doesn't learn new facts, but acquires the ability to recognize, remember, and imagine colors. Others suggest she gains a new way of knowing the same fact. She knew what red was physically, but now knows it experientially. The ability hypothesis, proposed by philosophers like David Lewis, compares Mary's situation to learning to ride a bicycle. You can know all the physics of bicycle riding without being able to ride one. What you lack is know-how, not factual knowledge. The phenomenal concept strategy suggests that Mary gains new concepts that allow her to think about brain states she already knew about in a new way. She doesn't learn new facts about the world, but new ways to conceptualize facts she already knew. These responses try to preserve physicalism by explaining Mary's new knowledge in terms that don't require non-physical facts about consciousness. The knowledge argument touches on fundamental questions about consciousness. Is consciousness something over and above physical processes? Can subjective experience be fully explained in objective terms? Can science, as we currently conceive it, explain consciousness completely? These questions continue to divide philosophers and scientists studying the mind. Whether Jackson's argument ultimately succeeds or fails, it forces us to confront the mysterious relationship between physical reality and conscious experience, the binding problem. Look at an apple. You see its roundness, its redness, its glossy surface, all as a unified object. but your brain processes these features in different regions. Color in one area, shape in another, texture in a third. How does your brain bind these separate processes into one coherent experience? This is the binding problem, one of the most puzzling issues in consciousness research. The binding problem isn't just about visual perception. It's about how your conscious experience holds together as a unified whole, despite your brain processing different aspects of reality in different places. When you bite into the apple, you simultaneously experience its taste, texture, sound, and appearance as aspects of a single event, not as disconnected sensation. Neuroscientists have discovered that different brain areas specialize in processing different features. The visual cortex has regions for color, motion, shape, and more. Yet somehow these distributed processes get integrated into your seamless conscious experience. It's as if there's an orchestra with no conductor, yet the music comes out perfectly synchronized. Several theories try to explain this mysterious binding. The feature integration theory developed by Anne Treisman suggests that attention acts like a spotlight, selecting which features get bound together. When you focus on the apple, your attention binds its features into a unified object representation. Another approach proposes that neurons representing different features of the same object fire in synchrony. They literally hum together at the same frequency. This temporal synchrony hypothesis suggests that the brain binds information by timing. Features belonging to the same object are processed in the same time window. The binding problem gets even more complex when we consider consciousness as a whole. Your experience at any moment includes not just perceptions, but thoughts, emotions, bodily sensations, and a sense of self, all somehow bound together into a unified field of consciousness. How does the brain create this unity? Some theorists, like neuroscientist Giulio Tononi, suggest that consciousness itself is essentially a binding process, the integration of information across the brain. According to Tononi's integrated information theory, the more integrated a system's information is, the more conscious it is. The binding problem has implications beyond neuroscience. It challenges computational models of mind by highlighting the integration that seems central to consciousness. Digital computers process information in separate modules, but consciousness seems fundamentally unified. Can artificial systems ever replicate this unity? Whether through attention, neural synchrony, or information integration, the binding problem reminds us that consciousness isn't just about processing information. It's about bringing it together into the seamless, unified experience we each know from the inside, the unity of consciousness. At this moment, you're simultaneously aware of these words, the feeling of your body in space, background sounds, perhaps a slight hunger or thirst, fleeting thoughts and emotions, all as part of a single unified experience. This seamless integration is what philosophers call the unity of consciousness, and it's one of the most fundamental yet mysterious aspects of being aware. The unity of consciousness refers to how all your experiences at a given moment belong to a single subject, you. Your visual field doesn't split into disconnected regions. Your sense of hearing doesn't fragment from your sense of touch. Everything comes together as one integrated experience. This unity has several dimensions. Spatial unity means you experience the world as a coherent spatial field. Temporal unity means your experiences flow continuously through time. Subject unity means all your experiences feel like they belong to the same self. And access unity means different contents of your consciousness can interact. You can compare a sound to a color or connect a feeling to a thought. What makes this unity puzzling is that the brain isn't unified at all. Different brain regions process different aspects of experience, with no single consciousness center where everything comes together. There's no neurological equivalent to the unified field of your awareness, no place where it all comes together. Philosopher Immanuel Kant argued that unity is a fundamental feature of consciousness, not something built from separate parts. The unity comes first, the distinctions come later. Modern philosophers like Barry Dainton suggest that consciousness is inherently unified. Its unity isn't something added on, but is essential to what consciousness is. The unity of consciousness creates challenges for scientific theories of mind. How can a distributed network of neural processes create a unified experience? Some researchers, like Bernard Baars with his global workspace theory, suggest that information becomes conscious when it's broadly shared across the brain, creating a kind of virtual unity from distributed processes. The unity of consciousness can break down in certain conditions. In split brain patients whose corpus callosum, the bundle of nerves connecting the brain hemispheres, has been cut, consciousness can become partially disunified, with each hemisphere having experiences the other doesn't access. Psychiatric conditions like dissociative identity disorder may also involve breakdown in the usual unity of consciousness. Whether consciousness is fundamentally unified or whether unity is something the brain constructs remains debated. But the seamless, integrated nature of our moment-to-moment experience stands as one of consciousness's most remarkable features. This unity, the way all aspects of our awareness belong to a single field of experience, gives our consciousness its coherence and makes our mental lives possible. Stream of consciousness. Your thoughts right now flow like a river. One idea leads to another. Memories bubble up unexpectedly. Sensations come and go, all blending together in a continuous flow. This ongoing parade of thoughts, perceptions, feelings, and memories is what William James called the stream of consciousness in his groundbreaking 1890 work, Principles of Psychology. James wrote, "Consciousness does not appear to itself chopped up in bits. It flows. A river or a stream are the metaphors by which it is most naturally described. This flowing, ever-changing quality is fundamental to how we experience our mental lives. The stream of consciousness isn't just random mental activity. It has structure and patterns. It includes both things you're focusing on, like these words, and things at the periphery of awareness, like the feeling of your clothes against your skin. It contains both perceptions of the external world and internal mental events like daydreams, memories, and emotions. What's fascinating about this stream is that it feels continuous, even though it isn't. Experiments show that consciousness actually comes in discrete moments, like frames in a film that appear continuous when played at the right speed. Our brains create the illusion of continuity by filling in the gaps between these moments. The stream of consciousness varies dramatically across different states. In focused attention, the stream narrows as you zero in on something specific. In relaxed daydreaming, it broadens and meanders. In meditation, it can become calm and clear. In sleep, especially during dreams, it becomes more bizarre and disorganized, free from the constraints of logic and physical reality. Writers like James Joyce, Virginia Woolf, and Jack Kerouac tried to capture this flowing quality of consciousness in their stream of consciousness writing style, which mimics the jumping, associative nature of thought rather than following logical or chronological order. This approach attempts to represent consciousness as it's actually experienced, with all its detours, associations, and half-formed ideas. Modern neuroscience has begun mapping the brain mechanisms behind the stream of consciousness. The default mode network, a set of interconnected brain regions, seems particularly active when the mind wanders. Other networks handle focused attention, emotional processing, and sensory awareness, all contributing to the ongoing stream. Perhaps the most mysterious aspect of the stream is that it happens to someone, to you. There's a quality of mindness to the stream. These thoughts and experiences belong to you in a way that others' experiences don't. This sense of ownership and subjectivity remains one of the hardest aspects of consciousness to explain scientifically. The stream of consciousness represents the dynamic, ever-changing nature of awareness, not a static state, but a process, flowing moment by moment like a river that never steps in the same water twice. Conscious realism. Imagine flipping everything you thought you knew about reality. What if consciousness isn't something produced by our brains? What if consciousness is fundamental, and the physical world, including our brains, is what's derived? This is conscious realism, a provocative theory developed by cognitive scientist Donald Hoffman. According to Hoffman, our perception of physical objects in space and time isn't a faithful representation of an objective reality. It's a user interface constructed by consciousness. Think of your computer desktop. The colorful icons you interact with aren't what's really happening inside your computer's processors and memory chips. They're simplified interfaces that help you use the computer without understanding its intricate working. Hoffman suggests our perception of reality works the same way. We perceive a world of physical objects not because that's what reality actually is, but because this interface helped our ancestors survive and reproduce. In Hoffman's framework, what exists fundamentally are conscious agents that interact according to mathematical rules. These conscious agents aren't located in physical space because space itself is part of the interface, not fundamental reality. The physical world is more like a shared hallucination constructed by consciousness for evolutionary fitness, not for truth. This sounds wild, but Hoffman bases his theory on evolutionary game theory and mathematical models. His simulations suggest that organisms that see reality accurately will be outcompeted by organisms that see what helps them survive. Truth and fitness are often at odds, and evolution favors fitness. As he puts it, perception is not about truth, it's about having kids. Hoffman's theory aligns with certain interpretations of quantum mechanics, where observation seems to play a crucial role in determining physical reality. It also resonates with ancient philosophical traditions like Advaita Vedanta, which view consciousness as the foundation of reality. Critics argue that if our perceptions were completely detached from reality, science wouldn't work. Our theories successfully predict phenomena we've never observed before, suggesting our perceptions capture at least some truth about reality. Others question whether conscious realism actually explains consciousness or just relocates the mystery. If consciousness is fundamental, what explains its nature and structure? Despite these challenges, conscious realism offers a fascinating alternative to both materialism and dualism. Instead of struggling to explain how physical processes produce consciousness, it suggests that consciousness is primary and physics emerges from it. Hoffman's theory reminds us that our deeply held intuitions about reality might be shaped more by evolutionary pressures than by access to objective truth. If he's right, the physical world we experience might be more like a virtual reality than an accurate picture of what's fundamentally real. The holographic principle. What if our three-dimensional reality is actually encoded on a two-dimensional surface, like a hologram? This mind-bending possibility, called the holographic principle, emerged from theoretical physics, but has profound implications for consciousness. The principle originated in the 1990s when physicist Leonard Susskind, building on work by Stephen Hawking and others, proposed that all the information contained in a volume of space can be represented on its boundary. Imagine everything happening inside a room being completely described by information written on the walls. This isn't just a wild speculation. It's grounded in black hole physics, where Hawking showed that a black hole's entropy, roughly its information content, is proportional to its surface area, not its volume, as we might expect. This strange relationship suggests that information in our universe might be fundamentally 2D, with our 3D experience being a kind of projection. What does this have to do with consciousness? Some theorists, most notably neuroscientist Carl Pribram and physicist David Bohm, proposed that the brain works like a hologram. In a physical hologram, every part contains information about the whole image. Similarly, memory and consciousness might be distributed throughout the brain rather than stored in specific locations. According to this holographic brain theory, memories aren't stored like files in a computer, but are encoded in interference patterns across the brain, similar to how a hologram stores an image in interference patterns of light. This would explain why memories can survive substantial brain damage and why they're associated with broad patterns of brain activity rather than specific cells. Taking this further, some suggest consciousness itself might be holographic, just as a 3D holographic image emerges from a 2D surface. Our rich conscious experience might emerge from simpler patterns of information processing. This could help explain the binding problem, how different aspects of experience come together into a unified whole. The Dutch physicist Gerard 't Hooft has suggested that the holographic principle might provide a path to understanding consciousness. If reality is fundamentally informational and holographic, perhaps consciousness is too. Critics point out that these ideas remain speculative. While the holographic principle has solid foundations in physics, applying it to consciousness requires leaps that many scientists aren't ready to make. The analogy between cosmological holography and brain function might be just that, an analogy, not a direct application. Nevertheless, the holographic principle reminds us that reality may be far stranger than our intuitions suggest. If space itself can be an emergent property of information on a boundary, perhaps consciousness too might emerge from patterns we don't yet understand. It invites us to think beyond conventional frameworks when tackling the mystery of consciousness. The simulation hypothesis. What if everything you experience, the world around you, other people, even your own thoughts and feelings, is actually part of an elaborate computer simulation? This is the simulation hypothesis, popularized by philosopher Nick Bostrom in 2003, which proposes that what we perceive as reality could actually be a sophisticated virtual reality created by a more advanced civilization. Bostrom's argument goes like this. If technological civilizations don't go extinct before developing the capability to run detailed simulations of consciousness, and if they're interested in running such simulations, then there would likely be vastly more simulated consciousnesses than non-simulated ones. Statistically speaking, we're more likely to be among the simulated than the simulators. This isn't just sci-fi speculation. It's a logical extension of current technological trends. We already create increasingly sophisticated simulations, from video games to virtual reality. If computing power continues advancing, eventually we might create simulations indistinguishable from reality, populated by conscious entities who don't realize they're simulated. The simulation hypothesis raises profound questions about consciousness. If we're simulated, is our consciousness real? Does it matter? After all, your experiences would feel just as real to you whether they're generated by a biological brain or a sophisticated computer program. Perhaps consciousness is fundamentally computational, patterns of information processing that can be implemented in different substrates. Some take the simulation hypothesis as evidence for a kind of digital dualism. Just as a video game character is distinct from the code that generates it, perhaps our consciousness is somehow separate from the processes that create it. Our minds might be running on the substrate of the simulation while having their own distinct reality. The hypothesis connects to ancient philosophical questions about reality and illusion. Plato's allegory of the cave depicted humans experiencing only shadows of reality. Eastern philosophical traditions like Buddhism and Hinduism have long described the material world as Maya, illusion or appearance, rather than fundamental reality. Interestingly, some scientists have proposed tests for the simulation hypothesis. If reality is simulated, it might contain observable glitches or shortcuts taken by the simulators to save computational resources. Physicist James Gates has even claimed to find error-correcting codes used in computing in the equations of string theory, though most physicists remain skeptical. Whether you find it plausible or not, the simulation hypothesis forces us to question our assumptions about reality and consciousness. It suggests that what matters isn't whether our experiences correspond to some true reality, but the experiences themselves. Even in a simulation, consciousness, the felt quality of experience, would remain real to those experiencing it. Digital physics. Imagine the universe isn't smooth and continuous, but pixelated like a digital image, built from tiny, discrete units of space, time, and information. This is the core idea of digital physics, a framework suggesting reality, at its most fundamental level, might be more like a computer program than the smooth mathematical equations of traditional physics. Digital physics proposes that information, not matter or energy, is the most basic component of reality. The universe, according to this view, is essentially computational, a vast information processing system operating according to algorithmic rules. Physical laws aren't mathematical abstractions, but more like the code running the cosmic computer. This perspective gained traction in the late 20th century with pioneers like Edward Fredkin, who developed the concept of digital philosophy, and Stephen Wolfram, whose work on cellular automata showed how complex patterns can emerge from simple computational rules. Physicist John Wheeler captured the essence of this approach with his famous phrase, "it from bit," suggesting that physical objects, emerge from information. Bit. What makes digital physics relevant to consciousness is its radical reimagining of what reality is made of. If the universe is fundamentally computational, consciousness might be too. Rather than emerging from physical matter, consciousness might be a particular pattern of information processing, something that could potentially exist in any sufficiently complex computational system, whether biological or artificial. Some proponents of digital physics, like engineer and futurist Ray Kurzweil, suggest consciousness is essentially computational, a view that supports the possibility of mind uploading or artificial consciousness. Others, like physicist Roger Penrose, argue that consciousness involves quantum computations that can't be replicated by classical computers. Digital physics also connects to the simulation hypothesis. If reality is computational, it becomes easier to imagine how it could be simulated. Our universe might be a program running on a higher-level reality's equivalent of a computer. Critics point out several challenges. If space and time are discrete rather than continuous, we should observe limitations similar to the pixelation in digital images when we look closely enough. So far, experiments haven't revealed such fundamental graininess, though some theories of quantum gravity do predict a minimum length scale called the Planck length. Others argue that digital physics confuses the map with the territory. Just because we can model physical processes computationally doesn't mean reality itself is computational. The mathematics we use to describe reality might be discrete or computational, but reality itself could still be continuous and non-algorithmic. Digital physics remains speculative, but provides a fascinating framework for rethinking both the physical world and consciousness. If reality is built from information processing rather than material stuff, the gap between mind and matter might not be as wide as it seems. Quantum mind. Could the bizarre, counterintuitive properties of quantum physics help explain consciousness? This is the provocative idea behind quantum mind theories, which suggest that quantum processes in the brain might be crucial for generating conscious experience. Classical physics, with its deterministic, clockwork-like mechanisms, has struggled to explain consciousness. Quantum physics, with its uncertainty, superposition, and non-locality, offers tantalizingly strange properties that seem somehow more compatible with the mysterious nature of consciousness. The most famous quantum mind theory comes from mathematician and physicist Roger Penrose and anesthesiologist Stuart Hameroff. Their orchestrated objective reduction, OR theory, proposes that quantum computations in microtubules, protein structures within neurons, generate consciousness. According to this theory, quantum effects allow for a kind of computing power beyond classical systems, potentially bridging the gap between brain processes and conscious experience. Other quantum mind theories focus on different aspects of quantum mechanics. Some suggest that quantum entanglement, where particles remain connected across distances, might explain the unity of consciousness. Others propose that the observer effect in quantum physics, where measurements influence quantum systems, might relate to how consciousness interacts with the physical world. The quantum approach addresses several paradoxes of consciousness. The seemingly non-algorithmic nature of understanding could result from quantum computation. The unity of consciousness might emerge from quantum coherence, multiple quantum elements acting as a single system, and the apparent causal power of consciousness might connect to quantum indeterminism, where outcomes aren't fully determined by prior physical states. However, these theories face serious challenges. The brain is warm, wet, and busy, conditions that typically cause quantum effects to disappear rapidly through a process called decoherence. Most neuroscientists believe the brain operates primarily through classical mechanisms like electrochemical signaling between neurons, not quantum processes. Critics also argue that quantum mind theories sometimes use quantum physics as a placeholder for mystery rather than providing specific mechanisms. Just because consciousness and quantum physics are both strange doesn't mean they're connected. As philosopher David Chalmers notes, quantum mechanics might explain certain brain processes, but the hard problem of why these processes generate conscious experience remains. Despite these challenges, the quantum mind approach continues to intrigue researchers. If conventional neuroscience can't fully explain consciousness, perhaps we need unconventional physics. Recent discoveries about quantum effects in biological systems, like photosynthesis and bird navigation, suggest quantum processes might play more roles in biology than previously thought. Whether quantum physics turns out to be central to consciousness or not, quantum mind theories remind us that our understanding of both physics and consciousness remains incomplete, with unexpected connections potentially waiting to be discovered. Orchestrated objective reduction. Imagine your brain as a quantum computer, not just a classical one. That's the wild idea behind orchestrated objective reduction, or ORC-R for short. Dreamed up by physicist Roger Penrose and anesthesiologist Stuart Hameroff, this theory suggests consciousness emerges from quantum processes in brain cells. Here's the gist. Tiny protein structures called microtubules inside neurons might host quantum computations. When these quantum states reach a critical threshold, they collapse or reduce in an orchestrated way, giving rise to conscious moment. It's like millions of tiny quantum collapses, creating the symphony of your awareness. Critics say the brain is too warm and wet for quantum effects to matter. They argue that quantum states would decohere, fall apart, too quickly. But Hameroff counters that microtubules might provide the perfect sheltered environment for quantum processes. What's fascinating is how this bridges physics and neuroscience. If true, it would mean consciousness isn't just neurons firing. It's connected to fundamental physical properties of the universe itself. Your thoughts would literally be quantum events, tying your mind to the deepest fabric of reality. Is it true? We don't know yet, but it's one of the few theories that tries to explain why consciousness feels the way it does from the bottom up. Split brain consciousness. When neurosurgeons cut the corpus callosum, the bundle of nerves connecting your brain's hemispheres, strange things happen to consciousness. This procedure, once used to treat severe epilepsy, created the perfect natural experiment for understanding consciousness. Roger Sperry and Michael Gazzaniga studied these split-brain patients in the 1960s, discovering something stunning. When information was shown only to the right hemisphere, the left hemisphere, which controls speech, couldn't verbally report it. It's as if two separate conscious entities emerged within one skull. In one famous experiment, researchers flashed the word key to a patient's right visual field, processed by the left brain, and ring to the left visual field, processed by the right brain. When asked what they saw, the patient said key, but their left hand, controlled by the right brain, pointed to a picture of a ring. This raises profound questions. Does a split-brain patient have one consciousness or two? If two, where was that second consciousness before the surgery? The left hemisphere can talk about its experiences, but the right hemisphere must communicate nonverbally, yet both seem aware. Some philosophers use this to argue consciousness isn't unified at all, but a collection of processes we experience as unified. Maybe our sense of being a single, coherent self is actually an illusion, created by the usual communication between brain hemispheres. What's particularly unsettling is how the speaking hemisphere will confabulate, make up stories to explain actions initiated by the other hemisphere. If shown a picture of a snowy scene in their left visual field, patients might use their left hand to point to a snow shovel. When asked why, they don't say, "I don't know." Instead, the speaking left hemisphere invents a reason: to clean out the chicken coop. Split brain research reveals how fragile our unified conscious experience might be, suggesting our sense of self depends on physical connections we take for granted. Multiple drafts theory. Forget the idea of consciousness as a single stream running through your mind. Daniel Dennett's multiple drafts theory throws that notion out the window. Instead, he suggests your brain is constantly creating multiple drafts of experience that compete for dominance. Think about watching a movie. You don't experience each frame separately. Your brain creates a seamless flow. According to Dennett, that's because consciousness isn't a precise timeline where things happen in order. It's more like your brain constantly editing and revising its story of what's happening. Here's a famous example Dennett uses: the color phi phenomenon. If you show someone two dots flashing in sequence, first red, then green, people often report seeing the dot move and change color midway. But how could you see the color change before seeing the second dot? Dennett argues there's no single moment when consciousness happens. Instead, your brain constructs a narrative after the fact. This theory directly challenges the idea of a Cartesian theater, an imaginary place in your mind where everything comes together and consciousness happens. There's no central headquarters where the you sits watching experiences. Instead, different brain processes create different interpretations simultaneously. What's particularly unsettling about multiple drafts theory is its implications for our sense of self. If consciousness is just competing narratives with no central viewer, then who exactly are you? Dennett suggests the self is another construction, a center of narrative gravity that emerges from these competing drafts. The theory explains weird phenomena like change blindness, when people fail to notice obvious changes in their visual field, and inattentional blindness, not seeing things right in front of you when focused elsewhere. These aren't flaws in consciousness. They're revealing how consciousness actually works by constructing limited, useful drafts of reality rather than perfectly representing everything. Multiple drafts theory reminds us that consciousness isn't a passive receiving of information, but an active construction process. Your experience right now isn't a perfect representation of reality. It's your brain's currently winning draft. Neural correlates of consciousness. What exactly happens in your brain when you're conscious? That's the question driving the search for neural correlates of consciousness, NCCs. These are the specific brain patterns and activities that correspond directly to conscious experiences. The hunt for NCCs isn't just academic. It has enormous practical implications. Doctors assessing patients in comas or under anesthesia need reliable markers of consciousness. Without them, we risk treating conscious beings as unconscious, or vice versa. Some of the most compelling work comes from Giulio Tononi and Christoph Koch, who've spent decades mapping consciousness in the brain. They've found that consciousness isn't just about which parts of the brain are active, but how those parts communicate. When you're conscious, different brain regions share information in complex integrated patterns. During unconscious states like deep sleep or anesthesia, brain regions still work, but they stop talking to each other effectively. The thalamocortical system seems particularly important. Damaged thalamus often means damaged consciousness, but it's not that simple. Patients with hydrocephalus, where cerebrospinal fluid replaces much of the brain tissue, can remain fully conscious despite having drastically reduced brain matter. This suggests consciousness isn't tied to specific brain regions, so much as to particular patterns of neuronal activity. Recent technology has opened new windows into these patterns. Functional MRI can track blood flow in the brain, while EEG captures electrical activity across the scalp. More invasive techniques like intracranial recordings directly measure neural firing. Each approach reveals different aspects of the conscious brain. What makes this research especially challenging is separating the neural correlates of consciousness itself from those of specific conscious contents. The brain activity corresponding to seeing a red square differs from that of hearing a violin, but both experiences share the property of being conscious. Researchers must distinguish between the what of experience, content, and the how of experience, consciousness itself. Ultimately, finding reliable NCCs could bridge the explanatory gap between physical brain processes and subjective experience, perhaps finally explaining how 3 pounds of wet tissue can generate the rich inner life we all take for granted. Extended mind thesis. Your mind might be bigger than you think. It could extend beyond your skull. That's the provocative claim of the extended mind thesis, developed by philosophers Andy Clark and David Chalmers. Think about how you use your smartphone. You don't memorize phone numbers anymore. You store them externally. When you need directions, you don't mentally map the route. You follow GPS. According to Clark and Chalmers, these technologies aren't just tools. They're literally parts of your cognitive system. Your mind has extended into them. Their famous thought experiment involves Otto, a man with Alzheimer's, who carries a notebook everywhere to record important information. When Otto wants to visit the museum, he consults his notebook to find the address. Compare this to Inga, who remembers the museum's location naturally. Clark and Chalmers argue that Otto's notebook plays the same functional role for him that biological memory plays for Inga. So why shouldn't we consider the notebook part of Otto's cognitive system? The boundary between mind and world, they suggest, is far more porous than we typically assume. Your cognitive processes don't end at your skin. They loop out into the environment and back again. This isn't just philosophical wordplay. The extended mind thesis challenges fundamental assumptions about what minds are and where they reside. It suggests consciousness might not be purely contained in the brain, but distributed across brain-body world systems. Critics argue that external tools lack the right kind of integration with our biological systems to count as mind. They point out that losing your smartphone feels nothing like brain damage. But proponents counter that the boundaries of mind should be drawn according to functional role, not biological makeup. This theory has profound implications for how we think about technology. Your devices aren't just convenient. They're becoming part of your extended cognitive architecture. When you use Google to answer a question, that process isn't fundamentally different from retrieving a memory. The extended mind thesis forces us to reconsider what it means to be human in a technological age. Perhaps what makes us special isn't just what's inside our heads, but our unique ability to incorporate external objects and technologies into our thinking systems. Embodied cognition. Forget the idea that your brain is like a computer processing abstract symbols. Embodied cognition argues that thinking depends fundamentally on your physical body. Your mind isn't just in your head. It's shaped by your entire bodily experience. Consider language. We describe understanding as grasping concepts or seeing points. These aren't random metaphors. They reflect how deeply our thinking is grounded in physical experience. Research shows that when you read action words like kick or pick up, the motor regions of your brain associated with legs or hands become active. Your understanding is literally embodied. Emotional states demonstrate this vividly. When you're happy, you stand taller. When sad, you slump. But it works both ways. Forcing a smile can actually make you feel happier. Your bodily posture doesn't just express your thoughts. It helps create them. Psychologist Arthur Glenberg showed this with a clever experiment. He had people evaluate positive and negative statements while either pushing a table away, rejection gesture, or pulling it toward themselves. Acceptance gesture. People judge statements as truer when their physical movement match the emotional content. Your bodily actions influence what you believe. This view radically challenges traditional cognitive science, which treats the brain as an information processor receiving input, computing, and producing output. Embodied cognition suggests instead that cognition emerges from the dynamic interaction between brain, body, and environment. Consider sports. A baseball player doesn't calculate precise trajectories to catch a fly ball. They move in ways that maintain certain visual relationships between themselves and the ball. Their thinking is distributed across their perceptual and motor system, not confined to abstract reasoning in the brain. Embodied cognition also explains why virtual reality can feel so convincing. By engaging your bodily senses in coordinated ways, VR hijacks the embodied nature of your cognition. The implications are far-reaching. If thinking depends on embodiment, then different bodies might enable fundamentally different kinds of thinking. This suggests that artificial intelligence lacking human-like embodiment might never think like us, regardless of computational power. For philosophers, embodied cognition challenges the ancient mind-body dualism. Your thinking isn't occurring in some abstract mental realm separate from physical reality. It's thoroughly grounded in your existence as a physical being in a physical world. Enactivism. Forget passive perception. Your mind actively creates its own world. That's the radical claim of enactivism, a theory suggesting consciousness emerges from our interactions with the environment. Rather than just receiving information, we enact our experiences through engagement with the world. Consider vision. Traditional theories suggest your eyes capture images like cameras, sending data to your brain for processing. Enactivism flips this on its head. When you see a coffee cup, you're not passively recording its features. You're exploring possibilities for action. You perceive it as graspable or contains liquid because vision evolved for doing, not just knowing. Pioneered by Francisco Varela, Evan Thompson, and Eleanor Roche in their 1991 book, The Embodied Mind, Enactivism draws inspiration from phenomenology, Buddhism, and biology. They argue that living organisms don't just process information. They generate meaning through their interactions with the environment. A fascinating example comes from experiments with sensory substitution devices. People who are blind can learn to see using devices that convert visual information into tactile or auditory patterns. Remarkably, after adaptation, they report genuinely visual experiences, not just translated touch or sound. This suggests perception isn't about specific sensory channels, but about mastering sensorimotor contingencies, understanding how your actions change your sensation. Enactivism challenges the boundary between mind and world. Your consciousness doesn't just happen inside your head, it's a relational process spanning brain, body, and environment. Your experience of a sunset isn't a picture in your mind, but an achievement of skilled engagement with the world. This approach transforms how we understand social cognition too. Traditional views suggest we understand others by theorizing about their hidden mental states. Enactivism argues instead that we directly perceive others' emotions and intentions through their embodied expressions and actions. We see the anger in the frown, not just infer it. For artificial intelligence, enactivism suggests that true consciousness might require not just sophisticated computation, but genuine embodied interaction with an environment. A disembodied algorithm, no matter how complex, might never truly understand the world the way we do. Ultimately, enactivism reminds us that consciousness isn't something that happens to us, it's something we do. Your awareness right now is an achievement of your active engagement with the world, not just a picture being painted on the canvas of your mind. The free energy principle. Your brain might be a prediction machine constantly trying to minimize surprise. That's the essence of Carl Friston's free energy principle, an ambitious theory aiming to explain all biological self-organization. including consciousness, under a single mathematical framework. The core idea sounds deceptively simple. Living systems work to minimize the difference between what they expect to experience and what they actually experience. This difference is called free energy, though it's not the same as the thermodynamic concept. Think about walking downstairs. Your brain predicts each step's location. If you encounter an unexpected extra step, you experience surprise or prediction error. Your brain quickly updates its model to minimize similar errors in the future. This principle operates at every level of biological organization. Single-celled organisms move toward expected chemical environments. Your immune system learns to predict normal cellular patterns and attacks unexpected ones. Your brain constantly refines its internal model of the world to better predict sensory inputs. What makes this theory revolutionary is its scope. Friston argues that consciousness, perception, learning, and even evolution can all be understood through this single principle. Perception becomes a process of using sensory data to test and refine predictions. Learning means improving your predictive model. Consciousness itself might be what it feels like to be a prediction-generating system. The mathematics behind the free energy principle is complex, drawing on Bayesian inference, information theory, and thermodynamics. But the intuition is straightforward. Biological systems survive by maintaining themselves in expected states, which requires minimizing surprise. This theory elegantly explains many cognitive phenomena. Optical illusions happen when your brain sticks with predictions that usually work despite contradictory evidence. Hallucinations occur when your brain gives too much weight to predictions over actual sensory data. Autism might involve placing too much emphasis on prediction errors, making the world seem overwhelmingly unpredictable. Critics wonder if a single principle can really explain everything from cellular behavior to consciousness. Some argue it's too abstract to generate testable predictions. Others question whether minimizing surprise actually explains why consciousness feels the way it does. Despite these challenges, the free energy principle represents one of the most ambitious attempts to unify our understanding of life and mind under a single theoretical framework, suggesting your conscious experience right now might be your brain's best guess about its own state and the world around it. Predictive processing. Your brain isn't just recording the world, it's constantly predicting it. This is the core insight of predictive processing, a revolutionary framework transforming our understanding of perception, action, and consciousness itself. Traditional views suggested your brain builds perceptions from the bottom up, starting with raw sensory data. Predictive processing flips this on its head. Your brain is constantly generating top-down predictions about what it expects to experience, then comparing these predictions with incoming sensory information. What you consciously perceive is the brain's best guess about the causes of its sensory input. Consider reading this text. You're not consciously processing each letter and word. Instead, your brain predicts what words and meanings to expect based on context, grammar, and prior knowledge. You only notice when predictions fail, like if this sentence suddenly contained an unexpected elephant. This explains many perceptual quirks. Optical illusions occur when your brain sticks with predictions that usually work despite contradictory evidence. The hollow mask illusion is a perfect example. You'll see a hollow mask as convex because your brain strongly predicts faces bulge outward, overriding the actual visual data. What makes this framework so powerful is how it unifies perception and action. When predictions don't match sensory input, you have two options: update your mental model, perception, or change the world to match your predictions, action. Reaching for a coffee cup involves predicting the sensations of holding it, then moving until those predictions come true. Predictive processing also helps explain psychiatric conditions. Hallucinations might occur when the brain gives too much weight to its predictions and not enough to sensory data. Autism could involve placing excessive emphasis on prediction errors, making the world seem overwhelming and unpredictable. Some theorists suggest consciousness itself emerges from this predictive machinery. The contents of consciousness might be the brain's best predictions about its own state and the world, predictions that have been refined through constant error correction. This view has profound implications. Your reality isn't a direct window onto the world. It's a controlled hallucination, a simulation constructed by your predictive brain. What you experience isn't what's out there, but what your brain predicts is most likely out there, given its model of the world and current sensory evidence. Predictive processing reminds us that perception isn't passive reception, but active construction. Your brain doesn't just reflect the world, it creates the only world you'll ever know. Sensorimotor Theory. How do you see red? Not just detect it, but experience that distinctive redness quality. Sensorimotor Theory offers a radical answer. Seeing red isn't about having certain brain states, but about mastering certain patterns of interaction with the world. Developed by philosophers Al Vanoy and J. Kevin O'Regan, Sensorimotor Theory challenges the assumption that consciousness happens inside the brain. Instead, it suggests conscious perception emerges from understanding the laws connecting your actions to sensory changes, what they call sensorimotor contingencies. Consider color perception. Traditional theories suggest seeing red means having specific neural activity in visual cortex. Sensorimotor theory proposes instead that experiencing red means implicitly knowing how red surfaces change appearance as lighting conditions shift, or how moving around them reveals their properties. The experience isn't in your head, it's in your skillful engagement with the environment. This explains why the same wavelength of light can appear as different colors depending on context. Your visual system isn't just detecting wavelengths, but interpreting surfaces based on how they reflect light under various conditions. Skills learned through interaction. Compelling evidence comes from sensory substitution experiments. People who are blind can learn to see using devices that convert visual information into tactile or auditory patterns. After adaptation, users report genuine visual experiences, not just translated touch or sound. This suggests perception isn't about which sensory channels you use, but about mastering the relationships between your actions and resulting sensory changes. For example, vision has specific sensory motor contingencies. Closing your eyes eliminates visual input. Moving your eyes changes your visual field in predictable ways. Once you master similar contingencies through a sensory substitution device, you begin having experiences qualitatively similar to vision, regardless of the sensory channel used. This theory challenges the search for neural correlates of consciousness. If conscious experience emerges from sensory motor skills rather than specific brain states, we may be looking in the wrong place for the neural signature of consciousness. Sensorimotor theory also explains why virtual reality can feel so convincing. By correctly simulating the sensorimotor contingencies of real environments, VR hijacks the very processes that generate normal perceptual experience. The implications are profound. Consciousness isn't something that happens to you in your brain. It's something you do through active engagement with the world. Your experience of reality right now is an achievement of skillful interaction, not a picture painted on a mental canvas. Phenomenology. Before brain scans and cognitive psychology, a group of philosophers developed a radical approach to studying consciousness, phenomenology. Instead of treating consciousness as an object to be observed from outside, phenomenology examines experience from the inside through rigorous first-person investigation. Founded by Edmund Husserl in the early 20th century, phenomenology asks us to temporarily suspend our assumptions about what causes our experiences, what Husserl called bracketing or epoche, rather than immediately explaining consciousness in terms of brain activity or environmental stimuli. Phenomenologists first describe experience exactly as it presents itself. This approach revealed overlooked structures of consciousness. For instance, Whenever you perceive something, you only see it from one perspective, yet you experience it as a complete object. Looking at a coffee mug, you only see one side, but you experience the hidden sides as implicitly present. Husserl called this interplay between presence and absence the horizon of experience. Martin Heidegger, Husserl's student, shifted phenomenology toward examining everyday lived experience. He noted that normally, you don't experience objects as neutral things, but as equipment for practical purposes. A door handle isn't primarily experienced as a metal object with certain properties. It shows up as something to grab to open the door. Only when equipment malfunctions do we notice its objective properties. Maurice Merleau-Ponty focused on the body's role in shaping experience. For him, perception isn't something happening in your brain. It's an activity of your entire embodied being. Your body isn't just another object in your experience. It's the very condition through which experience is possible. Phenomenology influenced fields far beyond philosophy. In psychiatry, it helped explain schizophrenia not just as brain dysfunction, but as an altered structure of experience. In cognitive science, it provided a sophisticated vocabulary for describing consciousness from the first-person perspective, complementing third-person approaches. Critics argue phenomenology lacks scientific rigor. Introspection seems too subjective for reliable knowledge. But defenders point out that consciousness is inherently subjective. Studying it without accounting for first-person experience misses the very thing we're trying to understand. Today, neurophenomenology combines phenomenological methods with neuroscience, training subjects in phenomenological techniques to provide more precise reports of experience that can be correlated with brain activity. Phenomenology reminds us that before explaining consciousness, we must carefully describe what we're trying to explain. Your experience right now has a complex structure that's easily overlooked when we rush to reduce it to neural mechanisms. Phenomenal intentionality. Every conscious experience is about something. When you see a tree, your experience isn't just green and brown patches, but of a tree. This aboutness of consciousness is called intentionality. But does intentionality come from how our minds connect to the world, or is it built into conscious experience itself? Phenomenal intentionality theory takes the radical position that consciousness inherently has intentionality. The very feel of your experiences, their phenomenal character, already contains their directedness toward objects, properties, and states of affairs. Traditional views separated phenomenal consciousness, how experiences feel, from intentionality, what they're about. On those views, the feeling of seeing red is one thing, while the fact that your experience represents a red apple is another. These might seem connected by convention or causal history, but not essentially. Phenomenal intentionality theorists like Uriah Kriegel and David Chalmers argue instead that the two are inseparable. The very feel of seeing red already contains its redness and out-there-ness. You can't separate the feeling from what it's about. The phenomenal character already includes intentional directedness. This has major implications. If intentionality is grounded in consciousness, then computers or other systems without consciousness might lack genuine intentionality. Their information processing might resemble intentionality, but it wouldn't be the real thing. This could mean AI systems, no matter how sophisticated, would never truly understand or represent the world the way conscious beings do. Consider the difference between Google Translate and a bilingual human. Both can translate sentences, but only the human genuinely understands what they mean. Phenomenal intentionality theory suggests this difference isn't just about complexity, but about the conscious experiences that ground true understanding. This view also challenges naturalistic accounts of intentionality that try to explain representation in purely physical terms. If intentionality is fundamentally phenomenal, we can't reduce it to causal relations or functional roles without explaining consciousness itself. Critics argue this makes intentionality mysterious rather than explaining it. If intentionality depends on consciousness, and consciousness itself is difficult to explain in physical terms, we've just pushed the problem back a step. Defenders counter that this is precisely the point. We can't fully naturalize intentionality without addressing the hard problem of consciousness. The very nature of aboutness may be tied to the subjective, first-person perspective that makes consciousness so puzzling. Phenomenal intentionality theory reminds us that consciousness isn't just how the world appears to us. It's what makes it possible for anything to appear to us at all. Intentionality. Your mind is always about something. Whether you're thinking of Paris, afraid of spiders, or desiring chocolate, your mental states point beyond themselves to objects, properties, or states of affairs. This distinctive aboutness of mental states is intentionality, and it's one of the mind's most puzzling features. Physical objects don't naturally point beyond themselves. A rock isn't about anything, yet somehow your thoughts hook onto the world. You can think about things that don't exist. Unicorns, events in the distant past or future, or abstract concepts like justice. This ability to represent things beyond itself makes consciousness fundamentally different from other physical phenomena. Franz Brentano, a 19th century philosopher, considered intentionality the mark of the mental, the defining feature that distinguishes minds from non-minds. For him, every mental phenomenon includes something as an object within itself. When you perceive a tree, the tree exists in your mind as an intentional object. Modern philosophers of mind face a challenging question. How does intentionality fit into a physical world? How can patterns of neural firing be about anything? Several approaches have emerged. Causal theories suggest mental states get their aboutness from appropriate causal relationships with what they represent. Your thought about trees represents trees because it's caused by experiences with trees. But this struggles to explain thoughts about things that don't exist or can't cause anything. Teleological theories ground intentionality in evolutionary function. Mental states represent what they evolved to track. Your visual system represents edges because detecting edges helped your ancestors survive. This handles misrepresentation neatly. A system can fail at what it evolved to do, but struggles with abstract concepts not directly tied to evolutionary advantages. Conceptual role theories locate intentionality in how mental states connect to each other. Your belief that water is wet represents what it does because of its relationships to other beliefs, perceptions, and actions involving water. This explains how complex concepts work, but risks making content too dependent on individual psychology. Phenomenal intentionality theory suggests that conscious experiences inherently have intentionality. The very feel of an experience already contains its aboutness. This explains the directness of conscious representation, but ties intentionality to the hard problem of consciousness itself. The intentionality problem continues to challenge philosophers precisely because it sits at the intersection of mind and world. Whatever consciousness ultimately is, its ability to be about things, to represent reality, remains one of its most remarkable and mysterious features. Awareness versus consciousness. Is being aware the same as being conscious? Though we often use these terms interchangeably, many researchers now draw crucial distinctions between them, distinctions that might help solve fundamental mysteries about the mind. Awareness typically refers to the detection and registration of information. Your brain can be aware of stimuli without you being consciously aware of them. For example, in blindsight, people with damage to visual cortex claim they can't see objects in certain parts of their visual field, yet when forced to guess about those invisible objects, they're remarkably accurate. Their brains are aware of the information, but they lack conscious experience of it. Consciousness, by contrast, often refers to subjective experience, what it feels like from the inside. It's the difference between a computer detecting light patterns and you experiencing the vibrant red of a sunset. Awareness might be necessary for consciousness, but many argue it's not sufficient. This distinction plays out dramatically in the phenomenon of subliminal perception. Flashing words too quickly to consciously perceive can still influence your behavior. Your brain processes, is aware of, the information without it entering consciousness. Some theories suggest awareness becomes consciousness when information becomes widely available throughout the brain, what Bernard Baars calls the global workspace. Others, like Giulio Tononi, propose consciousness emerges when information is both integrated, unified into a coherent whole, and differentiated, containing many distinctions. You might be aware of many separate pieces of information, but consciousness requires binding them into a unified experience. The distinction has profound ethical implications. Medical conditions like vegetative states involve awareness without clear consciousness. Patients might react to stimuli, awareness, without having subjective experience, consciousness. Determining which patients have which capacities is crucial for treatment decisions. Similarly, as artificial intelligence becomes more sophisticated, distinguishing systems that are merely aware, detecting and processing information, from those that might be conscious, having subjective experience, becomes ethically important. A system could pass the Turing test by skillfully processing information without having any internal experience. Some Eastern philosophical traditions have long emphasized this distinction. Mindfulness meditation, for instance, cultivates a state where you become conscious of awareness itself, noticing not just objects of awareness, but the process of being aware. The awareness-consciousness distinction reminds us that the mind operates on multiple levels simultaneously. Much of what your brain does happens outside the spotlight of consciousness, in the vast darkness of mere awareness, processing that shapes your behavior without ever entering your subjective experience. Self-consciousness. You're not just conscious of the world, you're conscious of being conscious. This recursive awareness, this ability to take your own mind as an object of attention, is self-consciousness. It's what allows you to think, I am thinking, or to reflect on your own experiences, beliefs, and desires. Unlike basic consciousness, which many animals likely possess, human self-consciousness involves sophisticated metacognition, thinking about thinking. You can evaluate your own mental processes, recognize your thoughts as yours, and distinguish your perspective from others. This creates the sense of being a continuous self, persisting through time. Self-consciousness emerges gradually in childhood. Around 18 months, toddlers begin recognizing themselves in mirrors, the famous mirror test that only a few species pass. By age 4, children develop theory of mind, understanding that others have different beliefs and knowledge than they do. These milestones mark crucial developments in self-awareness. Philosophers distinguish several types of self-consciousness. Pre-reflective self-consciousness is the basic sense of ownership that accompanies all experience. Your awareness that you are the one seeing, thinking, or feeling. Reflective self-consciousness involves explicitly directing attention toward yourself, examining your thoughts and sensations as objects. Self-consciousness creates both possibilities and problems. It enables planning, self-improvement, and moral responsibility. You can commit to future goals, evaluate your actions against your values, and hold yourself accountable precisely because you can reflect on yourself as a continuing entity. Yet self-consciousness also brings existential anxiety. You become aware of your mortality, worry about how others perceive you, and question your life's meaning. Jean-Paul Sartre described the unease of being watched, suddenly becoming intensely self-conscious under another's gaze, feeling yourself transformed into an object in their perception. Neuroscientifically, self-consciousness involves specific brain networks, particularly the default mode network, which activates when you're not focused on external tasks, but instead engaged in self-reflection, mind-wandering, or thinking about others' mental states. Various psychological and neurological conditions alter self-consciousness. Schizophrenia often involves disrupted sense of agency, uncertainty about which thoughts and actions are your own. Depersonalization disorder creates feelings of detachment from yourself, as if observing your experiences from outside. Self-consciousness may be uniquely human in its fullest form, though rudimentary versions exist in other species. This capacity to turn consciousness back on itself, to know that you know, creates the distinctive character of human experience, allowing us to narrate our lives, question our existence, and recognize ourselves as selves in a world of others. The narrative self. Our lives are stories we tell ourselves. The narrative self is the ongoing autobiography we construct to make sense of our experiences, weaving memories, goals, and social roles into a coherent identity. This isn't just abstract philosophy. It's how we actually experience being human. Think about it. When someone asks, "Who are you?" Zrenia, вы ответите story. Maybe it's about being a doctor, a parent, someone who overcame challenges, or someone with certain beliefs. These aren't random facts. They're episodes and themes in your personal narrative. The philosopher Paul Ricoeur described this process as narrative identity, arguing that we understand ourselves through the stories we tell about our lives. We're constantly editing this narrative, highlighting certain events while downplaying others. When we experience failure, we might frame it as character building to maintain narrative coherence. Importantly, our narrative self isn't just private, it's socially constructed. Our culture provides templates for what makes a good story or a successful life. We absorb these templates and use them to shape our own narratives, often unconsciously. This view of selfhood has profound implications. If our identity is essentially a story, then it's malleable. We can rewrite parts of it. Psychotherapy often works by helping people revise damaging narratives about themselves. "I'm a failure" becomes "I've faced challenges, but I'm resilient." But the narrative self has limitations. Our stories simplify the messy complexity of experience, creating artificial coherence. We might ignore contradictions in our behavior or retroactively justify decisions to fit our self-concept. And some experiences, like profound meditation states, seem to transcend narrative entirely. Still, the narrative view captures something essential about human experience. We are meaning makers, constantly interpreting our lives through stories. Without this narrative thread, our experiences would remain fragmented, lacking the continuity we recognize as a self. The minimal self. Strip away your memories, your plans, your beliefs. What remains? According to the minimal self theory, something fundamental persists, a basic sense of ownership and agency over your immediate experience. This isn't the rich, autobiographical self of narrative psychology, but something more primitive and essential. The minimal self is pre-reflective. You don't think about it, you live it. When you reach for a coffee cup, you don't explicitly think, "I am moving my arm." There's just an immediate sense that this movement belongs to you. It's this basic mindness of experience that constitutes the minimal self. Philosophers like Edmund Husserl and Sean Gallagher have distinguished between this minimal, core self and our more elaborate self-conceptions. The minimal self doesn't depend on memory or language. It's an immediate awareness that emerges with each present experience. What makes this theory compelling is its grounding in cognitive science and phenomenology. Studies with schizophrenic patients who experience thought insertion, believing their thoughts belong to someone else, show how disruption to this basic sense of ownership can be profoundly disorienting. Meanwhile, certain brain injuries can damage autobiographical memory while leaving this core sense of self intact. The minimal self theory also helps explain the persistence of selfhood across different states of consciousness. In dreams, during meditation, or under psychedelics, our narrative identity often fragments, yet some basic sense of I-ness remains. The experience still belongs to someone. Crucially, this minimal self isn't a thing or substance, it's a process. As philosopher Dan Zahavi puts it, it's the how, rather than the what, of experience. It's not something we find by looking inward. It's the very perspective from which looking happens. This view offers an intriguing middle ground in debates about selfhood. Against those who claim the self is entirely illusory, It identifies something real and experientially verifiable. Yet, unlike traditional Western views, it doesn't posit a permanent, substantial self separate from experience. The minimal self reminds us that before we are storytellers, we are embodied beings with a fundamental, pre-reflective awareness of our own existence. Something so basic we rarely notice it, yet something without which our experience would be unrecognizable. The no-self theory. What if the self you take for granted as the core of your being doesn't actually exist? This isn't just a philosophical thought experiment. It's the radical claim of no-self theory, most famously articulated in Buddhist philosophy as anatta or not self. The no-self theory doesn't deny that we have experiences. Rather, it argues that what we call the self is just a collection of constantly changing physical and mental processes with nothing permanent behind them. When we search for a solid, unchanging I within our experience, we find only thoughts, sensations, and perceptions in continuous flux. This view directly challenges our intuitive sense of being a distinct, continuous entity that owns experiences. According to no-self theory, this feeling of having a self is itself just another mental event, a useful fiction generated by the mind. As the Buddha put it, we mistakenly identify with the five aggregates: form, feeling, perception, mental formations, and consciousness, believing, this is mine, this I am, this is myself. Western philosophers have articulated similar views. David Hume famously wrote that when he looked within himself, he found only particular perceptions, never a self that was having them. More recently, Thomas Metzinger has argued that the self is a transparent self-model, a representation created by the brain that doesn't recognize itself as a representation. The no-self theory isn't just philosophical speculation. It's supported by neuroscience and psychology. Studies on decision-making suggest that our sense of conscious agency is often constructed after the fact. Meanwhile, research on meditation shows practitioners can temporarily disrupt the usual sense of being a separate self. What would accepting this view mean for daily life? Not necessarily nihilism or despair. Proponents argue that recognizing the self as constructed can be liberating, freeing us from excessive self-concern. If I am just a process rather than a fixed entity, there's no permanent self to protect or preserve at all costs. This doesn't mean abandoning practical identity. We can acknowledge the conventional usefulness of the self-concept while recognizing its ultimate emptiness, what Buddhists call the two truths. Like a useful fiction, the self helps us navigate daily life even if it doesn't bear the metaphysical weight we place on it. The ego tunnel. Imagine you're not directly perceiving reality, but living inside a sophisticated simulation created by your brain. This isn't science fiction. It's the ego tunnel theory proposed by philosopher Thomas Metzinger, offering a provocative account of consciousness and selfhood. According to Metzinger, what we experience as reality is actually a highly edited model created by our brains. Evolution has designed this model to be transparent. We don't perceive it as a model at all, but as direct access to the world. It's like watching a movie without realizing you're in a theater. The tunnel metaphor suggests that our consciousness is narrow, selecting only a tiny fraction of available information. Everything we experience, colors, sounds, emotions, even our sense of having a self, exists within this model, not in the outside world. As Metzinger puts it, nobody has ever been or had a self. What makes this theory fascinating is how it explains the feeling of being someone. The brain creates a self-model, a representation of itself that doesn't recognize itself as a representation. This self-model is transparent. We look through it, not at it. The result is the compelling illusion of being a self navigating an external world. The ego tunnel theory draws on neuroscience and experimental psychology. For instance, researchers can create out-of-body experiences by manipulating sensory input, showing how easily our sense of bodily location can be fooled. Such phenomena reveal the constructed nature of our experience. Metzinger doesn't claim consciousness itself is an illusion. The experience is real. What's illusory is our interpretation of this experience as direct access to reality and as evidence for a substantial self. We're conscious, but not in the way we think we are. This view has profound implications. If the self is a model rather than a substance, traditional notions of personal identity become questionable. And if our experience is a brain-generated simulation, philosophical questions about perception need rethinking. The ego tunnel theory offers a naturalistic explanation of consciousness without denying its reality. It walks a middle path between eliminative materialism, which denies consciousness exists, and dualism, which places it outside the physical world. Instead, consciousness is real but representational, not a direct window onto reality, but a useful model serving biological needs. Solipsism. What if you're the only mind that exists, and everything else, other people, animals, the entire universe, is just part of your mental experience? This is solipsism, perhaps philosophy's most radical and disturbing hypothesis about consciousness. The solipsist doesn't deny the existence of experience. Rather, they claim that only their experience exists. Your thoughts, feelings, and perceptions are real, but the external world, including other apparent minds, exists only as content within your consciousness. In the starkest version of this view, you're not a mind in the world. The world is in your mind. While few philosophers openly embrace solipsism, its logical appeal is undeniable. After all, you only ever directly access your own consciousness. Everything else, including evidence for other minds, comes to you through your perceptions and thoughts. How can you step outside your experience to verify anything exists beyond it? René Descartes approached this problem in his famous thought experiment, imagining an evil demon creating the illusion of an external world. While Descartes ultimately rejected solipsism, his cogito ergo sum, I think, therefore I am, acknowledged that one's own existence is the only immediately certain thing. The pragmatic argument against solipsism is simple. It's unlivable. Even committed theoretical solipsists interact with others as if they were conscious beings. As philosopher Ludwig Wittgenstein suggested, solipsism collapses in practice because language itself presupposes a community of minds. Yet solipsism haunts philosophy precisely because it can't be definitively refuted. Other minds remain fundamentally inaccessible. We infer their existence from behavior, but never directly experience another's consciousness. This is the problem of other minds, which forces us to acknowledge the limits of what we can know with certainty. Solipsism also appears in different forms across various traditions. Some interpretations of Yogacara Buddhism suggest that reality is mind only, though this usually refers to a universal consciousness rather than an individual mind. Meanwhile, some quantum mechanics interpretations propose that observation plays a role in determining reality, though this falls far short of solipsism's radical claims. While few seriously advocate solipsism today, it serves an important philosophical function, highlighting the subjective nature of experience and the epistemological limits we face when considering consciousness. It's the logical endpoint of radical skepticism, a position most philosophers find compelling in theory, but impossible in practice. Neutral monism. What if reality at its most fundamental level is neither physical nor mental, but something else entirely, something neutral that gives rise to both matter and mind? This is neutral monism, a fascinating middle path between the extremes of materialism and idealism. Traditional metaphysics often presents us with an uncomfortable choice. Either mind emerges from matter, materialism, or matter emerges from mind, idealism. Neutral monism rejects this dichotomy, proposing that both the physical and the mental are different aspects or organizations of the same underlying neutral stuff. William James and Bertrand Russell championed this view in different forms. James suggested that pure experience was the fundamental reality prior to the distinction between subject and object. For Russell, the basic constituents were events, neither inherently mental nor physical, but capable of being organized into either physical objects or minds depending on their relationships. What makes neutral monism appealing is how it addresses the mind-body problem. Rather than struggling to explain how consciousness emerges from physical processes or how mental processes could affect the physical world, it sees both as different expressions of the same underlying reality, like two sides of a coin. Consider your experience of seeing a red apple. The materialist focuses on the brain processes involved, while the idealist emphasizes the subjective experience of redness. The neutral monist says, both perspectives capture different aspects of the same fundamental events, organized in different ways. This view resonates with certain interpretations of quantum physics, where the line between observer and observed blurs. It also aligns with aspects of Eastern philosophical traditions, like Advaita Vedanta, which sees the ultimate reality as neither material nor mental, but a non-dual awareness. Critics argue that neutral monism merely postpones the hard problem of consciousness rather than solving it. What exactly is this neutral stuff, and how does it give rise to such different phenomena as physical objects and conscious experiences? The theory often struggles to characterize the neutral basis without defaulting to either mental or physical terms. Despite these challenges, neutral monism offers an elegant way to avoid both the reductionism of materialism and the counterintuitive implications of idealism. It acknowledges the reality of consciousness without divorcing it from the physical world, suggesting instead that the mental-physical divide might be a human construct rather than a fundamental feature of reality. Dual aspect monism. What if mind and matter aren't two separate substances, but two different ways of looking at the same underlying reality? This is dual aspect monism, a theory that offers an elegant solution to the mind-body problem while avoiding the extremes of both dualism and reductive materialism. Imagine a coin with heads and tails, obviously different sides, yet inseparable aspects of a single object. Dual aspect monism suggests consciousness and physical processes relate in a similar way. They're not two different things interacting mysteriously, but two perspectives on the same underlying reality. Baruch Spinoza developed an early version of this view, arguing that mind and body are two attributes of a single substance he called God or nature. Modern proponents include physicist Arthur Eddington and philosopher David Chalmers, who suggests consciousness might be the intrinsic nature of processes that, when viewed from the outside, appear as physical brain activity. The appeal of this theory lies in its elegance. It explains why consciousness and brain activity correlate so perfectly without reducing one to the other. It's like reading the same novel in different languages. The content remains consistent while the expression changes. Take pain as an example. From an external perspective, we observe neural firing patterns. From the first-person perspective, there's the feeling of pain itself. These aren't competing explanations. They're complementary views of the same phenomenon, like seeing a building from the inside and outside simultaneously. This approach resonates with certain interpretations of quantum physics, particularly Niels Bohr's complementarity principle, which holds that some quantum phenomena must be understood through complementary, seemingly contradictory descriptions. It also aligns with aspects of Eastern philosophical traditions that emphasize non-duality. Critics argue that dual-aspect monism struggles to specify exactly what the underlying reality is without lapsing into either physicalist or mentalist language. There's also the question of why some physical systems, like brains, have experiential aspects, while others apparently don't. Despite these challenges, dual-aspect monism offers an attractive middle path. It acknowledges the reality and uniqueness of consciousness without making it something separate from the physical world. It suggests that the seemingly unbridgeable gap between objective science and subjective experience might result from our limited perspectives rather than reflecting a fundamental division in reality itself. Scientific realism. The subatomic particles, electromagnetic fields, and black holes described by physicists. Do they actually exist, or are they just useful tools for prediction? Scientific realism takes a bold stance. Our best scientific theories don't just save the phenomena, they describe what reality is actually like, even in domains we can't directly observe. Scientific realists argue that the remarkable success of science would be a miracle if our theories weren't at least approximately true. How could we successfully predict eclipses, build semiconductors, or create vaccines if our understanding of electrons, DNA, and viruses was merely a convenient fiction? The fact that science works suggests it's getting at something real. This position doesn't claim science has achieved complete truth. Rather, it holds that successful scientific theories typically capture aspects of reality, even while containing errors. Newton's physics wasn't completely wrong. It accurately described many aspects of motion, even though Einstein later provided a better account. Scientific knowledge is progressive, getting closer to truth over time. What makes scientific realism particularly relevant to consciousness studies is its implications for theories about the mind. If scientific realism extends to neuroscience, then descriptions of neural correlates of consciousness aren't just useful models. They're telling us something true about what consciousness actually is or how it arises. Critics raise several challenges. The pessimistic meta-induction argument notes that past scientific theories we once thought true were later rejected, suggesting today's theories might share the same fate. The underdetermination problem points out that multiple incompatible theories can explain the same evidence, undermining claims of discovering the one true theory. For consciousness specifically, scientific realism faces the explanatory gap. How could physical processes, no matter how complex, create subjective experience? Some argue that consciousness presents unique challenges to the realist perspective because it straddles the objective-subjective divide. Moderate versions of scientific realism avoid some of these pitfalls. Structural realism, for instance, claims that science uncovers real structural relationships in nature, even if it doesn't provide a complete picture of what things are in themselves. This offers a way to explain scientific progress while acknowledging the limits of scientific knowledge. Scientific realism reminds us that science isn't just a game of prediction or a social construction. It's our best attempt to understand what reality is actually like. While this position faces genuine challenges, especially regarding consciousness, it captures something important about science's remarkable ability to unveil the hidden structures of our world. Anti-realism. Does science reveal the true nature of reality, or does it just provide useful models for prediction and control? Scientific anti-realism challenges our assumption that theories describe what's really out there, suggesting instead that they're sophisticated tools, useful but not necessarily true in any deep sense. Unlike direct skepticism about reality itself, anti-realism primarily questions our ability to know unobservable aspects of the world. When physicists talk about electrons or quantum fields, anti-realists don't claim these entities definitely don't exist. They argue we should remain agnostic about their reality and focus instead on the observable predictions theories make. Bas van Frassen's constructive empiricism exemplifies this approach, arguing that science aims for empirical adequacy, not truth. For van Frassen, accepting a scientific theory doesn't require believing its claims about unobservable entities, only that it correctly predicts observable phenomena. The rest is unnecessary metaphysical baggage. This position gains support from the history of science. Theories once considered obviously true, like the luminiferous ether or phlogiston, were later abandoned entirely. If past scientific realities proved illusory, why assume current theories have finally got things right? Perhaps today's quarks and strings will join phlogiston in the graveyard of discarded scientific concepts. Applied to consciousness studies, anti-realism suggests caution about theories claiming to explain subjective experience through brain mechanisms. Even if a neural theory perfectly predicts when conscious experiences occur, anti-realists would question whether it truly explains what consciousness is. The gap between prediction and ontological truth remains unbridged. Anti-realism connects with broader philosophical traditions, questioning our access to reality in itself. Kant argued we can never know things in themselves, only how they appear to us. More radically, social constructivists suggest scientific facts are partly constructed through human practices rather than simply discovered. Critics argue anti-realism can't explain science's remarkable success. How could theories making claims about unobservable entities be so effective if those entities don't reflect something real? The no miracles argument suggests the best explanation for science's predictive power is that theories approximate truth about what exists. What makes anti-realism valuable isn't necessarily its correctness, but its humility. By reminding us of the gap between successful prediction and metaphysical truth, it encourages epistemic modesty, particularly important when confronting something as mysterious as consciousness, where the limits of scientific understanding may be most apparent. Structural realism. What if science tells us about the structure of reality, but not its intrinsic nature? This is structural realism, a nuanced position that preserves what's most compelling about scientific realism while avoiding its biggest pitfalls. Structural realism emerged as a response to a troubling dilemma. The success of science suggests our theories capture something true about reality, the no miracles argument. Yet history shows scientific theories regularly get overturned, with fundamental entities like phlogiston or the luminiferous ether discarded entirely, the pessimistic meta-induction. The solution? Perhaps what survives through scientific revolutions isn't the entities theories postulate, but the mathematical structures they describe. When we moved from Newton's to Einstein's physics, the specific concepts changed dramatically, but many of the mathematical relationships remained intact or were refined. John Worrell, who revived this idea in modern philosophy, points to the example of light. Fresnel's 19th century theory correctly described many of light's mathematical properties, while incorrectly viewing it as a mechanical ether vibration. Maxwell later reconceived light as electromagnetic waves, preserving many of Fresnel's equations while replacing the underlying picture of reality. Applied to consciousness, structural realism suggests we might understand the relationships between neural states and conscious experiences without necessarily knowing what consciousness really is in itself. We might map the structure connecting brain activity and subjective reports without grasping the intrinsic nature of experience. This connects with Bertrand Russell's insight that physics describes the mathematical relations between events, but remains silent about their intrinsic nature. Russell suggested consciousness might represent this missing intrinsic aspect of reality, a view now called Russellian monism. Some philosophers distinguish between epistemic structural realism, we can only know structural aspects of reality, and ontic structural realism, reality itself is fundamentally structural, with no intrinsic nature behind the structure. The latter, more radical view suggests relations are more fundamental than the things being related. Critics question whether we can meaningfully separate structure from the entities structured. They also ask whether structural realism merely postpones rather than resolves the philosophical problems with scientific realism. Despite these challenges, structural realism offers a sophisticated middle path, acknowledging both science's remarkable success and its historical limitations. It suggests that science progressively unveils the mathematical skeleton of reality, even as our picture of what fills in that skeleton continues to evolve. Naive realism. Look around you, you see objects, colors, people, the world as it really is, right? This intuitive view that perception provides direct, unmediated access to reality is naive realism. It's called naive not as an insult, but because it reflects our pre-theoretical common-sense understanding of perception. According to naive realism, when you see a red apple, You're directly aware of the apple and its redness, not mental representations or sense data. The world you perceive is the actual world, not a construction or model in your mind. This view suggests a fundamental continuity between mind and world. Perception connects us directly to reality rather than isolating us from it. This position feels obvious in everyday life. We naturally assume we're seeing things as they really are. But this intuitive view faces serious challenges from both science and philosophy. Physics tells us objects aren't colored in themselves. Color results from how surfaces reflect light and how our visual systems process those reflections. Neuroscience shows that perception involves extensive processing and construction, not passive reception. The argument from illusion presents another challenge. When you experience optical illusions, dreams, or hallucinations, you perceive things that don't correspond to external reality. If perception sometimes misrepresents the world, how can we claim it generally gives us direct access to reality? Despite these objections, naive realism has experienced a surprising revival in contemporary philosophy. Defenders argue that perception can be direct even while involving complex processing. They distinguish between the vehicle of perception, the brain processes involved, and its object, what we perceive, arguing that the former's complexity doesn't undermine the latter's directness. Some proponents, like John Campbell, argue that naive realism better explains how perception grounds our concepts and knowledge. If perception only provides access to internal representations, how do we ever establish what our concepts refer to in the external world? For consciousness studies, naive realism suggests perception isn't something that happens in the head, but a direct relationship between perceiver and world. This challenges internalist accounts that locate consciousness entirely within the brain, suggesting instead that conscious experience spans the brain-world boundary. While naive realism might ultimately prove untenable in its strongest forms, it reminds us that any adequate theory of perception must explain its apparent directness. Whatever perception involves, it presents itself as a window onto the world, not a screen displaying internal models.